door is divided into two parts, isn't it? Now the door is divided into three parts. Now at a time, I want all the 6% to enter the room. One person is equal to how much? I said 1 standard deviation. All right. Now to the right side of the center line, how many people are entering the room? Come on, yeah. How many? I'm telling a story, and story also you people are not listening, right? So 3 people are entering the
Entering the
door,
door.
isn't it? To the right of the center line. And another
Yes, sir.
3 people are entering through the door on the
Right,
left of
left
the
of the
center
center
line.
line.
So totally how many people are entering the door? 6 people.
6 people.
3 on the right side, 3 on the left side.
Yes, sir.
And this is known as 3 sigma process. This is known as 3 sigma process. All right. But if you somehow either you whether the door is bigger or the number of people who are entering are smaller, what will happen? The capability will increase, right? If the kind of
Yes, sir.
people who enter the door, if they are much smaller, then what will happen? Even more than 6 people can enter. If 8 people can enter, then the process is 4 sigma process. If 10 people can enter, then the process is
10 sigma plus. Oh, sir.
Right.
5 sigma plus.
5, 6.
I
5 sigma
I
plus.
even warn all of you. This way of learning is not at all going to help you. You have to come face to face, number one. Another thing is you have to interact and you have to, remove your fear and shyness. If you hesitate a lot to speak, I don't think you are going to learn, right? And
Okay,
that
sir.
will be a further complication to your, understanding. So when 6 people are entering, we call the process as 3 sigma process
Sigma.
because 3 on the right, 3 on the left. When
Yes,
8
sir.
people are entering, the process is
4
4
4
sigma.
sigma
sigma.
plus.
When 10 people can enter,
5 sigma.
5, 6.
that's all. Now when 12 people can enter,
6,
6 sigma.
now you know the meaning of 6 sigma, isn't it? From the
Yes, sir.
center up to the specification, if we can fit 6 standard deviation, then only the process is known as 6 sigma
6 sigma
process.
plus.
And what will be the success rate or success probability for a 6 sigma process? 99 point?
9.
Very good.
Triple
99.999. And this is a long-term success rate, not a short-term success rate. All right. So long-term,
Yes.
always, in the long term, the process will lose the capability. But we are saying that the 99.999 is possible even in the long term. That is the advantage with Six Sigma capability. All right. So then we also understood some other things like the points which are at 3 standard deviation away from the center. How are they called? The points which are at 3 standard deviation away from the process center. They are known as
Specification limits.
not specification limits. Specification limits are normally provided by the customer. There is no formula there, right? And let me ask the question in other words. What are control limits?
Control limits. Average plus minus 3 sigma.
Very good. Average plus 3 sigma is upper control limit. Average minus 3 sigma is lower control limit. When I say average, this is nothing but process average. All right. So this clarity we gained yesterday, and normal distribution curve will be a bell-shaped curve, right? And you can understand how your process is behaving by plotting a histogram. And the histogram, most of the time will reveal the bell shape. And you understand the extreme cases on the right and extreme cases on the left. And that's the purpose of the histogram. So now let us get into the measure phase today, 7 p.m. to till 8:30. I'm going to take you through the measure phase. And then after that, after the break, 8:45 onwards, Veeraraghavan will take you through the analyze phase. Very, very important learnings you are going to have today. So make sure you do not, fail to participate in all the chapters. All right. So the ultimate purpose of measure phase is to perfect our understanding of the define phase. What we did in the define phase, we have created a project charter, right? And we got the project charter approved. And now whether the understanding is correct or not, And what is our baseline performance? Baseline in the sense, our current level of performance. We know there is a problem, but how, right? And that is called baseline. So we want to get a accurate measure of the baseline performance. That is the purpose of measure phase. If you are concerned about the accuracy of the baseline performance, and you should have an accurate data with you. If your data is not accurate, automatically the baseline will not be accurate. Hope it is understood, right? It's very logical. If the data is not accurate, then your calculations cannot be accurate. Agreed?
Yes, sir.
Data is not accurate, your calculations cannot be accurate. So how can I make my data accurate? Then I need to collect the data very carefully, right? People should use the instrument properly, should handle the instrument and follow the proper instruction during the data collection. And in fact, there has to be a proper data collection plan that should be made available to the project team. Otherwise, what will happen? They will bring irrelevant data, which will not help you to calculate the accurate measure of the baseline. If you are concerned about the accuracy, yes, you must have a proper data collection plan, and then you must also ensure your measurement system is good. Can somebody here, can you answer, what is a measurement system? What do we mean by measurement system?
Today is going to teach about measure. I'll have this recorded also. Let's see. You know, you online to way different.
Okay. I think Elona Fernandez, are you talking to me? But she was also mentioning something about measure. Are you talking to me? Okay. So what do we mean by measurement system? The various elements that are
Physical
included in the
quantities.
yes?
Some
Yes, Amar, you are saying something. Yeah, come again.
physically quantity for the measurement.
Hmm.
Something. Sorry, sir. It's
No,
like
no
this.
problem. See, just you try, you all have to try. And in case you don't know, and one of you should say, then no problem. I don't have to wait, and then I can say. Measurement system means there are different elements put together. Always different elements together is known as system. When I say measurement system, I need a measuring instrument. I need a person to use the instrument. Yes, sir. And the person should be given proper instruction. And there should be some product or some characteristics that the person has to measure, isn't it? And there will be some environment. All these elements put together is known as measurement system. All the elements together is known as measurement system. Is my measurement system okay or not? That you must first ensure even before collecting the data. So normally what people do is, particularly in a Six Sigma project, they will do a pilot data collection. What they will do? They will do a pilot data collection. They will collect about 90 sample data, and with the help of the 90 sample data, they will try to estimate whether the measurement system is okay or not okay. Right? If the measurement error is less than 10%, then measurement system is considered okay. Then data will be collected. And now the data is considered to be clean and credible. And use that data for calculating your baseline. Otherwise, what will happen? You will calculate something and you think that your baseline is this much, but actually that will not be the reality. You might calculate the accuracy and you think that it is 90%, but still customer complaints will keep on coming. From the customer side, they will say that you are not at 90%, you are at only 70%. So these kind of contradiction, disagreements will happen if you have a poor or weak measurement system in your place. All right. So you need to consider all of this and calculate the baseline. I think in yellow belt itself, you all have some understanding about operational definition. Am I correct?
Yes.
And data type also you all know. There are two types of data. What are the two types of data?
Qualitative and quantitative.
Qualitative is one thing, quantitative is one thing. Qualitative means there are no numbers. Let's say I take photo of all of you and send and share that photograph, with my boss. I'm sharing data it is. I collect all your photograph. That is a data. Is it a qualitative data or quantitative data?
Quantitative.
Come on, you choose. You have only two options. Half of you can choose qualitative and half of you can choose quantitative. Automatically, half of you will be correct. There are only two options, right? So try something instead of giving quiet. So photograph is,
Quantitative.
yeah, it's not quantitative. It is qualitative,
Okay.
right? Yeah, if I collect all your photograph, it is qualitative. If I collect all your age, I can see
Okay.
numbers.
Okay. Numbers.
Now
Numbers.
it is
Okay.
quantitative,
Correct, sir. Correct, sir.
right? This we studied already in yellow belt. There is no point of studying and forgetting. Whatever you study, you should be able to digest. You should be able to internalize so that you can move on to the advanced level. Otherwise, you have to start from the scratch every time. Okay. So there are two types. One is qualitative, other one is quantitative. Now within quantitative, there are two types. And let's say I want you to measure the room temperature. Will you be able to measure the room temperature? Correct, accurately?
If you have a thermometer.
Very good.
Thermometer.
If we have a
Yes.
thermometer, we can definitely measure the room temperature. Can your reading be accurate? Possible or not?
It will be continuous.
Yes, possible.
Possible. Accuracy is possible. Then if accuracy is possible, then your data should be called as a continuous data. You can measure and say, sir, the room temperature is 27.35 degrees Celsius. Do you understand?
Yes.
The data is continuous now because it is measurable. It has got some unit of measurement and I can even achieve the accuracy. Only thing is I have to be careful. I have to follow certain procedure and then collect the data. So it is accurate. But there is one more scenario where I want you to give a rating for the training you have undergone. Give a rating for the training you have undergone. And you are given a form to give your feedback. And under the rating column, you are given 5 options. If you are highly satisfied, you will give 5 out of 5. If you are highly dissatisfied, you give 1 out of 5. And in between values, you know the meaning. And now tell me, this way of collecting data, this is also quantitative. But can I consider this as continuous data?
No, sir.
Discrete.
Discrete.
This is
Discrete.
discrete. Now,
Discrete data.
how it is different from continuous data? In continuous data, decimals have come. And in continuous data, our characteristics is more accurate. But now what happens? Suppose for a trainer, you want to give 3.5. But can you give 3.5? You only have option of 3. Otherwise, you have option of 4. Am I correct?
Yes.
Correct, sir.
So you obviously tend to round off. Either if you want, if you want to favor the trainer, you will round it to the higher side. You will make it 4. Or you want to trouble him, you will round it to the other side. Isn't it? That means there is a
Yes, sir.
chance of accuracy loss. Can you see that? So such type of data are known as attribute data or discrete data. Only finite number of possibility values are accepted. 1, 2, 3, 4, 5. That's all. And generally it will be a whole number. Generally it will be a whole number and there will not be any unit of measurement associated. When I say 5, what is the unit? It is a dimensionless number. Yes or no? When you collect data and the data is dimensionless, there is no unit attached to it, then the data is discrete data.
Discrete.
Now I want to know how many people are currently on the video. How many people are on the video? Myself, Jayanti ma'am, and then Ruchita ma'am, right? How many are we? 3 people, right? Isn't it? I'm not asking you to come on video. I'm only asking you to count now. Now, how many people? There are 3 people, right? So this is the data. And now now 3 people are on the video. This is also discrete data. How many are not on video, of the video? 4, 8, 12, 13. So this is also discrete data. Do you understand?
Yes, sir.
How many children are there in your family? 2 children, 3, no, 2 children or 3. And these are all discrete data. Why? For all these number, there is no dimension. It is just a number. Can you see that, all of you?
Correct, correct, sir. Correct.
Now you know the meaning, what is continuous data and what is discrete data, right? And
So
now
if there's
for
no unit, it
There
will
is
be
no in-
discrete. Unit, it will be
very good.
discrete.
Yeah, if there is no unit, then it is discrete, dimensionless number. Okay, now you got it. Why this information is needed? And all normally for continuous data, we calculate average. We calculate average. But for discrete data, we calculate proportion, right? For continuous data, we calculate average and then interpret it. For discrete data, we calculate proportion and then interpret it. Let's say 100 people and 90 people have passed the exam. Now, number of people passed is 90 out of 100. Now I get 90%. Proportion or average?
Proportion.
Proportion. Very good.
Proportion.
So whenever you work with dimensionless number, 90 people passed is, it's just a number. So 90 upon 100 is 90%. But if I want to know the average height of the participants here, now I can measure all your height and then calculate the average height and come to an understanding that and the average height of the participant is 5.5 feet. All right. So,
Correct.
so when my data is continuous, I go with average. When my data is discrete, I go with proportion. So these are all, some understanding about the nature of the data. But what is very, very important is when you collect the data, your data should be free from error. Data should be free from error. So there are two things important. When you are concerned about the measurement error, there are two things. First requirement is data must be consistent, first of all. Data must be consistent. Suppose if I involve 3 people in data collection, all the 3 people should collect the data in a consistent manner, isn't it? The way procedure I follow, the procedure you follow, the procedure the other person follow, we all should follow the same procedure, isn't it? Because we all of us are trying to measure the same thing. So that is called consistency. If there is no consistency, there itself error will populate. All of you agree with me? If there
Yes,
is
sir.
no consistency,
Yes, sir.
there itself what will happen? The error will populate. So maybe we can also understand do a small exercise here to understand this. So what will I do is I will now want you to make a small measurement to understand this, right? The point here is we are trying to understand whether the data collected is consistent or not. Sometimes people call it as precision. The exact word is precision. Precision means consistent, right? And if the consistency is lost, then what will happen? The error is known as precision error. There are 2 types of precision error. One is known as repeatability error. The other one is known as reproducibility error. All multiple data collectors, the reproducibility error will populate. If I don't involve multiple appraiser, I only involve one appraiser, one person, then also an inconsistency is possible. That is known as repeatability error. That is known as repeatability error. So if there is only one data collector, the error populating will be called as repeatability error. If there are multiple appraiser, then reproducibility error. So,
Reproducible.
yeah, the sum of the two is known as precision error. So let's understand this with the live exercise. So I want all of you to open your smart stopwatch. Please open your stopwatch. I mean, you must, in your mobile phone, you must have the clock, and inside the clock, there should be a stopwatch. All right. And yeah. And now please open that stopwatch. And if you can find out the resolution of the stopwatch. Resolution is nothing but the least count. Can you please let me know on the least count of your stopwatch? Least count, all of you know what is least count?
Yes, sir.
What is it? Least count means what?
Minimum measurement scale.
Low.
Minimum
Very
measurement
good.
scale.
The minimum
The
possible
smallest
measurement.
measure.
Very good. What is the smallest measure from your stopwatch?
Millisecond.
Milliseconds. So whenever you use any unit, millisecond, whatever, you should know the definition of it. All right.
Yes, sir.
So what is millisecond? We all know 1
So,
second, isn't it?
mm,
Yes.
We all know what is 1 second. Then what is millisecond?
1,000th of a second is
Yeah.
millisecond.
Please check whether your phone can measure that. Can your phone measure 1/1000th of a second? Let me know. Look at your phone and what is the
It
last?
shows
How many
1
decimals
minute
are?
00.000.
It is,
Do you have? Can you show it on the screen? Do you have three decimals in the last? In my phone, that is not available. In my phone, only
I'll
the
just
Two decimal.
only 2 decimals are available. So 3 decimal available means millisecond. But 2 decimals only available. I think in your mobile also it is 2 decimals only. Am I right?
two decimals. Yes, sir.
Then you just have to call it as
Only
0.01 second.
0.01 second.
All of you agree with me?
Points
The least count is
second.
0.01 second. Clear, everyone?
Yes, sir.
So
Yes,
0.01 second. Very good. So now what will I do is, I will play a video from my side. I will play a video from my side. And you all have to measure the duration of the video. You all have to measure the duration of the video and type the reading in the chat box. This is known as operational definition. Do you think all of you can record the duration of the video? Or do you all know how to measure? Can one of you explain how the duration can be recorded?
So when the song will start, we have to start our stopwatch, and when the song stop, we have to stop, and then we have to write it in the chat box that what
Very
is the
good.
time.
And all of you, when you are writing the reading in the chat box, it should be in seconds only. No minutes allowed, right? No other milliseconds and all not allowed. Everything should be in seconds. And your reading should go up to 2 decimals. Understand? 30.23 seconds. So 2 decimals are needed. So with that note, so all of you please be ready with your, what do you call? The stopwatch. And I will be sharing my slide now. Just give me a minute. Okay, module 2, mashup phase. Yeah, here. Yeah, continuous data, discrete data, operational definition, and bias and gauge R&R. We are here at gauge R&R, right? Okay. So is my screen visible? I have got 3 songs for you.
Yes,
You are
sir.
going to measure them one by one and put the readings in the chat box. So which song you want to hear first? If you want, you can dance along with the song, right? No problem. Permission is granted, right? But what's very important is the accurate data is also important, right? No problem with the dance, but as long as your data is accurate. All right. So which one to go first? Any choice?
Dance.
Yes.
We'll go with Rowdy Baby, right? Okay. Okay.
Yes.
So all of
Okay.
you, please reset your stopwatch and be ready to start. And once the song stops, you have to stop and then type your readings in the chat box, right? So be ready. 3, 2, 1, and which means you measured the same characteristics 2 times, isn't it? You measured the same characteristic 2 times. Now look at the chat box and tell me how many of you got the same readings in both songs. There is some difference or some problem there also. Am I right?
Yes, sir.
So whenever your people collect data, we always ask them to collect data 2-3 times. You might have done this in your school and college also. Yes or no? your teacher and your professor always ask you to collect the data 2-3 times because they know you will commit experimental error. So in order to minimize the error, they will ask you to conduct the experiment 2 times, 3 times, and then later use the average in the formula. Yes or no? So I am checking
Yes,
your
sir.
ability to repeat the reading. In fact, I checked your ability to repeat the reading and found some problem there also. Am I correct?
Yes, sir.
This form of disagreement or this form of inconsistency,
Repeatability.
this form of variation is known as ability error. Hope all of you understand both the things, right? This, you need this study, you need to conduct when you are dealing with continuous data. Clear all of you? When you are dealing with
Yes, sir.
continuous data. 2 types of error. One is repeatability error, which is the variation within single appraiser's reading. Another one is reproducibility error, the variation between
Variations.
multiple appraisers. Together, when I sum them up, it is known as precision error. All of you are with me? What is precision error? The sum of repeatability error and reproducibility error. So I just take you through the slides again so that you can understand, all these things. So, yeah. See here, I did the similar exercise so many times with some people, and you can see so many readings. Now you could understand, definitely the readings have some amount of repeatability error and some amount of reproducibility error. Unless and until these errors are minimal, I can't use the data. You know the consequence, isn't it? If the errors are too high, then still I use the data, then all my statistics will go wrong, then my interpretation will also go wrong. There are certain ways to calculate the error, right? You don't have to worry. There are formulas. Later you can deep dive into the formula. See here, precision error means sum of repeatability error and reproducibility error. And now this precision error has to be compared against the tolerance. Normally we work within the tolerance. Normally we all work within the tolerance, isn't it? Let's say there is an upper limit and a lower limit. Let's say you are producing a product with where the dimensional requirement is 100 plus or minus 0.5 mm. Upper limit now 100.5. What is your lower limit now? 99.5. So what is the total tolerance you have? 100.5 minus 99.5. How much? If it is in mm, the tolerance itself is 1 mm. Yes or no? 0.5 mm on the right side, 0.5 mm on the left side. Now, what is 10% of 1 mm?
0.1.
0.1 mm. So 0.1 mm is the maximum error permissible. This is a industry guideline. As per AIAG, the Automotive Industry Action Group's guideline is gauge R&R should be less than 10%. Then only measurement system is considered valid. All right. And see here, gauge R&R is equal to precision error compared against tolerance. Tolerance means upper specification limit minus lower specification limit. You all know who will give the tolerance? Customer will give the tolerance. With respect to the tolerance, how much is our precision error? And so now the condition is written here. If the gauge R&R value, what is gauge R&R? Precision tolerance ratio. If the gauge R&R value is less than 10%, your measurement system is considered good and accepted. If it is 10 to 30%, conditionally accepted. If it is more than 30%, it is not acceptable. All of you are with me on this? Please make sure
Yes,
when
sir.
you are dealing with the continuous data, dealing with some kind of measurement system, first do a pilot data collection and try to get an estimate of the gauge R&R value. If the gauge R&R value is lesser than 10%, then only you can conclude your measurement system is valid and acceptable for
Robust.
Exactly. Otherwise, the measurement system is considered incapable. Hope the understandings are clear. And if you say yes, I can the calculation will work with the help of the Minitab, because at this stage, discussing about the formula and trying to do manually will be very tough for you. Maybe at a later stage when you want to learn, we can help you. But right now you can do all these things with the help of Minitab. So please tell me, are you good so far, or do you have any questions to ask before we go to the Minitab mode? Good to proceed?
Good. Good to proceed.
Confusions? Right? Great.
Good.
All
Good, sir.
right. Why are we very much concerned about all these small things? Can somebody answer this question?
Quality and customer satisfaction.
Customer satisfaction. And the kind
Quality.
of problem we are trying to solve is complex in nature. So we need to work with the facts, not with the assumption, isn't it?
Yes, sir.
Right? So we don't want to give any chance for any form of error which can deviate us in the wrong direction. Right? So that's why we are so much concerned. And let me open the Minitab for you now. Give me. So I think Minitab links are shared with all of you. Is that true?
Yes, sir.
Okay. So you all also can install the Minitab. When you install, it will ask for the product key. You can simply leave it blank and click the next button. What will happen? The Minitab will get installed, and that will work for 30 days. And after 30 days, you can start exploring the cloud version. And in order to use the cloud version, you just require a mail ID. That's all. So it is opening the Minitab. It will take some time. And we'll let the Minitab open. Prior to that, I will give you some guideline. See, when you want to do a MSA study or a Gage R&R study, some pilot data must be collected. How many readings you should collect? I told you. How many sample readings are needed?
19.
90 readings, 90.
Yeah.
And it should be in this manner. You take 10 sample parts. How many sample parts?
10.
10 sample parts.
10.
You don't have to know the true value of the parts, not required. It need not be a standard. Simply take 10 parts, but all the parts should be taken inside the upper specification limit and lower specification limit. Do you understand, all of you, what I am telling now? You please
Yes.
select 10 parts covering the entire tolerance. Let the screen is visible now, right?
Yes, sir.
Can you see me? Can you see me typing in Minitab? Yes. Let's say my upper specification limit is 110 and lower specification limit is
20.
now from 90 till 110. I want you to select 10 parts. Is it possible? Possible or not?
Yes, sir.
Yeah.
Possible.
90 mm, then 92 mm, 94 mm, something like that, right? 96. That way you will get 10 parts. These are the sample parts. And now I want you to write the parts here. Write the parts here. 10 parts, part number 1, part number 2, part number 3, part number 4, part number 5. That you have to type all 10 parts, etc., etc. And then operator. Who are operator? Sometimes they call it appraiser. Now I need to use 3 operators. Sometimes 2 also okay. So now there are 3 operators I am using. Operator A, B, and C. Now A will measure the first part, right? And get me the first reading. Measurement 1. I want him to measure the same part one more time. Measurement 2. I want the same part to be measured by the same person for the third time. Measurement 3. Now tell me how many parts? 10 parts.
10 parts.
And how many operators?
3.
3.
3 operators. And each operator will measure each part 3 times. So totally how many readings I will get?
3
30.
into 3 into 10.
30.
10 into 3
10
into
into
3.
3 into 3 equal to 90.
90. This is the logic. So you have to do a pilot study and generate the 90 readings. And how it must be organized in your Excel. For that, here there is a template available. Go to Stat, go to Quality Tools, then come to create, come to Gauge Study, and then you create a Gauge R&R study worksheet. Can you see here, all of you?
Yes, yes.
Yes, sir.
So you come here and number of parts you can type here 10 parts. Number of operators 3.
3.
And let's say I want to give the name of the operator, I can always do that. If I want to give the name of the operator, I can give whoever. I could see Ruchita and I could see Ria and I could see Amar now, right? So these three people are going to be my data collectors. Operators. Number of replicates. Each part, how many times we want to measure? 3 times. So I
3.
make it
3 times.
So 10 parts, and you can even name the parts, right? It can be just as it is, or you can also name it. No issues. Now, the 10 parts, 3 operators, number of replicates, 3. Now I give OK. Now, can you see a new worksheet getting generated? Run order,
Mm.
parts, operator, and here I will take my measurement. Now, the first reading will be produced by Ruchita. Ruchita will measure part number 2. All of you, do you understand?
Yes.
After that, Ruchita will go to part number 7 and get me a reading. Why am I following a random order? Because randomization is important to eliminate operator bias. To eliminate operator bias. So in this manner, I will engage Ruchita, I will engage Ria, I will engage Amar. All of them will depend on my instruction. According to my order only, they all will give me reading, and so 90 readings. Can you see that, all of you? 90 readings.
Yes.
Once these 90 readings are generated, you can ask the Minitab to analyze. Let me get all of you some sample reading because we don't have time to produce 90 reading. So I go to File, Open Worksheet, File, Open Worksheet, and this window comes. I have to click this green icon once. It reads like look in Minitab sample data folder. You click here once, and then you just have to type Gauge here. Then this file will appear, second file, Gauge aiag.mtw. After that, you have to click the open button. You click the open button and say OK. And now you have the sample data. Can you see here, all of you? Part number, operator, along with measurement this time. Can you see 90 readings?
Yes.
Yes.
Same situation. Now I just have to analyze. Now only additional requirement is I should declare upper limit and lower limit. Upper specification limit and lower specification limit. So I want you to go to Stat, come to Quality Tools, come to Gauge Study, and then after coming to Gauge Study, please choose Gauge R&R Study crossed. Can one of you read the description that Minitab is showing right now?
Assess the variation in your measurement system when every operator measures every part in the study.
All right.
Assess the
So assess
variation.
the variation in your measurement, right? And I click that. And now Minitab opens this window. And this window is asking me, where have you stored the part number? Which column contains part number? C1.
Second,
So you have to double click.
C2.
You have to double click. Now part number information is shared with Minitab. Operator detail stored in C2. In C3. Now there are 2 types of analysis. You can choose any one. And let us choose X bar and R. And then you go to option. Go to option. It is asking what is the lower specification, what is the upper specification. Either you must declare the upper spec and lower spec, or at least you should declare the difference. I want to declare the difference.
Tolerance.
In our case, what is our lower reading? I told you something. I told you, isn't it? 90 and 110, whatever. So it
Lower
can be
is 90
okay. Lower is 90, upper is 120,
and
110.
110.
I have some idea. So I know the range is 20. So I typed 20. All right. And now after giving all this, you give okay and you give one more okay. And now Minitab will do the job for me. Will do the job for me and generate me 6 different graphs. The purpose of these graphs is to point out which element of your measurement system is actually troubling you. Which element of the measurement system is contributing to the error? Whether repeatability is high or reproducibility is high. If reproducibility is high, which particular operator is disagreeing with others? If repeatability is high, who is actually contributing for more repeatability error? When we have to look at the data, each and every data, it is a tedious process, isn't it? You can't find out. So with the help of the graphs, that can be done beautifully. And we'll be slowly educating you on all these expertise. But right now, let me minimize this. I want to take you to the session window here. Session window reads like this: Gage R&R study, X bar R method. All right. And now there is a first table. I want you to skip the first table because there are 2 methods used here. At least one method you need to know. Leave the first method. Now come down to the second method. This is the second method. Now in the second method, read the second row. What is it? What is it showing? Total gauge R&R.
R&R.
How much is the gauge R&R value? Come to the last column and find out.
9.17.
9.17 is the gauge R&R value, which it means it is lesser than 10%. Your measurement system is acceptable if the tolerance is 20. Clear, all of you? If we change the tolerance, same measurement system might become unacceptable. Yes or no? When I declare 20, it is acceptable. Let me do something else. Stat. Can somebody guide me? After stat, where should I go?
Quality tools.
Gauge
Quality
study.
tools.
Gauge
And then I
study.
should go
Gauge
to
study.
Then tolerance gauge
Go to
study. Gauge
Gauge
study.
R&R.
Then
R&R study.
gauge
gauge
R&R
R&R study
study
crossed.
crossed.
Why I call it call the study as crossed? The same part is measured by all the 3 operators.
Okay.
If it is a destructive testing, my part will not be available to you because I am destructing, isn't it? So in that case, the study will become nested study.
Nested.
But right now, the same part can be shared by all of us. Like you all hear the same song which I played, isn't it? I didn't play different song. I played the same song and all of you enjoyed it. So it's all crossed study. So I choose crossed. All the informations are available. Now what I'm going to do is I'm going to change the tolerance. From 20, I'm going to make it 10. Now what will happen to the gauge R&R? It is supposed to increase because I'm reducing the tolerance. Can you see that?
Yes.
When I reduce the denominator, then the whole value will increase. Let's see how it affects my decision. I give okay and one more okay. And now again another graph comes. I minimize this. Come here, yeah. Now this is the second table. Now how much is the new
18.35.
gauge R&R?
18.35.
So now our conclusion
About
is
10%.
acceptable. Conditionally acceptable. In order to use this condition, you should know the limit and specification limit. How many of you know the meaning of control limit and specification limit here? All of you. Am I right? Because we
Yes,
have
sir.
taught you just yesterday only. You can't say no now. You all know what are control limit, what are specification limit, right? So if you want to still use the measurement system, the condition to be fulfilled is your control limit should be well inside the specification limit. If your control limits are well inside the specification limit, you can still use the same measurement system. Otherwise, it is very risky. You know what will be the risk? Your decision will go wrong. Your own quality inspector will measure the parts and reject them even though they are good. Do you understand? A good part will get rejected or a bad part might get accepted. What is the reason? Problem with the measurement system. Do you understand? If a good part is rejected, who is losing? The producer is losing or
Company.
the manufacturer is losing. Am I right or not?
Yes.
This is known as manufacturer's risk. Why that risk is happening? Because of the poor measurement system. Clear, 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 all of you. Please confirm. Understood?
Yes, sir.
Yes, sir.
Told you? Type 1 error. Type 1 error means a good part is getting rejected. Type 1 error means a good part is getting
Part is
rejected. This is also known as manufacturer's risk. In medical field, they call it false positive. The person do not have any disease, but still the medical report confirms that he is having the disease. Do you understand? The person is
Yes.
actually healthy, but what the report says, he is
Not healthy.
affected by some viral fever or something. The situation is known as false positive.
False positive.
Why this happened? Necessarily treated, getting treated for a problem. Treatment is not required. There is no problem at all. But people still, project it as if there is a. Why this happened? Because of the problem with the measurement system. Measurement error is the culprit here. Do you understand? We have seen many such cases, isn't it, in the corona time?
Yes.
Many people were taken to the hospital and they were there for 20, 30 days. They enjoyed the food and everything and then came back. That is because of poor measurement system. That's an example of type 1 error. Now, another possibility is also there. What is another possibility? They might accept a bad
They
product.
may be bad.
Now the consumer will be in trouble. The customer, isn't it? A bad product is classified as good product. Again,
Good
the reason is measurement error. What is the kind of error to happen? That is what is expressed here as 18%. That is what is expressed as 18%. 18% of the time, your decisions can go wrong. Do you want to maintain such a condition?
No.
No. That's why, the minimum requirement is 10%. If you can bring it well below 10%, that is still appreciable. All right. So there is manufacturer's risk, there is consumer risk. If you actually commit, if you accept, reject a good product, the error committed is known as type 1 error. In medical field, it is known as false positive.
False positive.
Similarly, if you accept a bad product must be rejected. But what do? You accept it. That is known as type 2 error.
Type 2 error.
In manufacturing
False
or
negative.
service. But in medical field, that is known as false
False
negative.
negative.
So please collect accurate information so that you don't your decisions will not get affected by the false positive or false negative scenario. All of you are with me on this? Very, very important.
Yes, sir.
Otherwise, many a times, you will end up making wrong decision. Hope the points are very clear, right? Let me give another simple example. An husband and wife, they are going to hospital, right? The lady is going for a pregnancy test, right? And her husband is going for a diabetic test. Clear? So both of them gave the sample. And the same day evening, they have to collect the result. And the report reads like the husband is pregnant and the lady is diabetic. Now what happened here? What happened here? What type of error happened here? Possible or not? Something went wrong. The samples got exchanged.
Switch swapped.
Isn't it? And then in the pregnancy report, the husband's name is appearing. And in the diabetic report, the lady's name is appearing. The procedure, no, there is a confusion. Yes or no? In the sample, a label has to be pasted. At the time of pasting the label, something went wrong. The instructions, gave room for the confusion to happen. As a result, we got into the error. Isn't it? This is a case of false positive, isn't it?
Yeah.
Right? So false positive error happened. So we need to avoid our understanding have to be very, very accurate. That's why we did a study known as Gage R&R study. Once if the Gage R&R study supports your measurement system is good to collect data. Otherwise, some improvement is needed. Now, what kind of improvements you can do to bring down this inconsistency? Tell me, all of you, what kind of improvements you will make? You have to give training to all the data collectors, am I right? Do you think hospitals have to train all the,
Operators
what they
has
call,
to be well
the
trained.
technicians in the laboratory?
You have to calibrate the
Required, isn't it?
systems.
How to do the pregnancy test and how to do the diabetic test, isn't it? And how to do the test for cholesterol. For everything, there is a procedure. Do you remember? Suppose you want to get tested for the fasting blood sugar. What is the procedure? The sample must be collected in an
Sample
empty
has to be
stomach.
collected.
In empty stomach.
Empty.
And then the previous day,
At
the
least
dinner,
12 hours of fasting
12
has to
hours
be there.
fast.
10 hours fasting.
And
So
then the
you have
sample has to be analyzed within a stipulated period of time.
correct. Sample has to be analyzed within stipulated period of time. Very good. All these points are known as operational definition. Instructions. Instructions have to be very, very clear. No ambiguity. No room for any confusion. If you say you finish your dinner earlier, there is a confusion possibility there. People can take the advantage of the word earlier. I normally take dinner at 12 o'clock. So since doctor advised me to take the dinner earlier, I'll take 30 minutes earlier. By 11:30, I'll take the dinner. And somehow our reading, will become useless. So instead of that, you reframe your statement in a way that everybody will follow. Thereby, you will get consistency in your reading. Otherwise, your consistency will get easily affected and there your precision will be lost. And we call it as precision error. And we measure it using the tool Gage R&R. Hope all of you understand the importance of measuring consistently. Why I am talking so much about consistency? Because consistency is the key for accuracy. If there is no consistency, there cannot be accuracy. Hope all of you agree with me on this. Yes or no? If your people
Yes,
are
sir.
not
Key
consistent in
to
measuring, how can they get me an accurate reading? Not possible. Okay. And now let us assume there are no problem with the consistency. Everybody is very clear with the understanding and everybody does the procedure in the same manner. So now I need to conduct another study known as bias. Another study known as bias. Now bias must be studied. Now the Gage R&R study is conducted and I satisfactory now. Gage R&R is less than 10%. Now I move on with the study for bias. Please all of you note, in order to conduct the bias, study for bias, you must have the standard. You must have standard piece or standard part or some reference part. Reference value must be available. That means you must maintain reference pieces, because reference pieces are considered to be the true value. True value should be known, then only you can calculate bias. All right. Now imagine, okay. Now imagine, now the time is 8:10 and suppose if your watch shows the time as 8:20, what does it mean? Your watch is 10 minutes faster.
Master.
Am I correct? This extra 10 minutes is known as bias. The extra 10 minutes is known as bias. In this
bias.
case, it is positive bias. All of you, do you understand what is bias?
Hmm.
The true value or the true time is 8:10 but the instrument reads as 820. As a result, there is a bias of 10 minutes, which is known as positive bias.
Positive bias.
If your watch is always running 10 minutes faster, do you think you can use your watch to find out the time?
No.
Possible or not? You know that your watch is 10
Yes, you
minutes
have to keep
faster.
minusing that
possible.
much time. Yes, possible.
Yeah. So yes, possible. Every time you read your watch, you know your watch is 10 minutes faster. So what will you do?
Right.
You will smartly
Minus 10.
subtract 10 minutes and then communicate the time. That means you are finding a way to convert your reading into an accurate reading. Isn't it? Even though your readings come with the bias, come with the error, you smartly eliminate the error by subtracting the value equal to the bias. Correct? In order to do this work, you should know the quantum of bias. Then only it is applicable. And moreover, the bias should be constant during the data collection. If the bias is not constant, if the bias is not stable, and you can't follow this procedure. This procedure is known as data calibration. All of you understand? This procedure is known as data calibration. A simple mathematical formula will convert my data into accurate data. What is the formula? Minus the value equal to bias. If my bias is negative, what will I do? I will add the bias. Sometimes bias is known as zero error. Sometimes bias is known as zero error.
Zero.
That means straight away, always some signal will be there in your instrument. You have not started measuring. That is nothing but bias, isn't it? Okay. Now imagine if your watch is not behaving in a stable manner. Earlier, the condition was running 10 minutes faster. The bias was stable. Suddenly, the bias become very dynamic. You all know the meaning of dynamic bias. What happens now?
They keep
Sometimes
changing.
the watch is 10 minutes faster.
10 minutes.
Sometimes your watch is 20 minutes faster. Sometimes your watch is slower. Sometimes it is 40 minutes slower. Do you think your watch is still usable?
No.
Now it is difficult, right? Now what will you do? You understand the time has come to get the watch serviced, isn't it? You will take it to the service center, and in the service center, they will change the battery. They will change the worn out parts, maybe whatever, screws that needs to be tightened, and all those small things, adjustment they will do. And then now the watch is again in a perfect condition. Now, if you look at the watch, absolutely there is no bias. This is called instrument calibration. Clear, all of you? So when the bias is not stable, calibration is compulsory. Instrument calibration is compulsory. Right? Maybe some adjustment in the instrument, some overhauling of the instrument, some kind of service needed, some parts needs to be changed. Please do that so that your instrument will become usable again. All right. And now one more thing. Now that you have the watch in a proper condition again, now you realize something means the watch needs a proper attention and proper maintenance, isn't it? You will handle it well, you will store it well, isn't it? And you use it properly, and because there is a cost involved if I don't follow all of this. But in spite of your efforts to make best use of the best way of maintaining the watch, after 6 months the same problem comes again. The same problem comes again. Now what will you do? You will again go to the service center, isn't it? You will again go to the service center. Probably this time the battery must be changed. Yes or no? Battery must be changed. And now you understand one more thing. Your watch needs attention once in 6 months. This is known as calibration frequency. This is known as calibration frequency. So, if you are dealing with the measurement system, you should know the nature of the bias that you're producing. If the bias is stable, it's not very troublesome. You can still handle the instrument and get accurate reading. But the moment you realize the bias is dynamic, now it must be calibrated. And if you are regularly using an instrument, a measurement system, you should have the knowledge about calibration frequency. At appropriate, you must calibrate the instrument and then take best care of the instrument. And usage instructions have to be followed very strictly. Yes or no? All of these things, if you do, your instrument will give bias-free readings. Otherwise, there will be bias. But please note, there are two sources of bias. What are the two sources of bias? One is there is a problem with the instrument. That can be rectified with the help of calibration. But one more source. What is the one more source? Earlier we discussed repeatability and reproducibility. That
Operator
cannot be
flexibility.
eliminated because human factor is involved, environment is involved. Yes or no? Not only instrument. You can't control everything, isn't it? Can you control other human beings? We all know, right? It's very, very difficult to control. And similarly, environment also to certain extent you can't control. So certain amount of bias will always be there in any reading. You must accept. Yes or no?
Yes, sir.
That's why
Yes, sir.
if that gauge R&R is less than 10%, your measurement system is considered good. But if you can bring it below 10%, scenario. Hope the gauge R&R study, all of you are able to understand how to conduct and what context and everything, I just made you to understand. So now I will only show the calculations of the bias here so that you will understand calculation of the bias is also not a big deal. Yeah. You see here, there is a standard part. What is the value of the standard here?
25.4.
25.4. The 25.4 is measured by an appraiser 10 times. And the appraiser produced these readings. What is the resolution of the instrument?
025.
What is the resolution here? What is the least count here? Look at the reading and tell me.
Point
0.025.
1.025.
Difficult. All questions are difficult here.
0.025 mm.
Are you sure?
Yes.
Resolution is
0.025.
Yes.
Okay.
0.025.
Okay.
Solution.
So 0.025 is the
25.
resolution. Okay. So you got it. So that's how it is. So resolution is 0.025. And anyway, the readings, that's why you have 3 decimals. And tolerance are also declared. And now
Plus
if there are
minus
10
0.25.
readings, please, what is the question?
No, the tolerance is plus minus 0.25.
Yeah. Tolerance is plus 0.25. Very good. And now 10 readings, you just have to calculate the average. Very simple. You add all the 10, divide by 10. And now this is the average, center value. And
Okay.
then you calculate the bias. The formula is the average
X bar.
and the true value. Difference between the average and the true value. Your average is on the higher side. So you are now getting a positive bias of 0.0051 millimeter. Every single reading is expected to have a bias of 0.0051 millimeter. Can you understand? Every single reading your team is producing is expected to have a bias of how much? 0.0051. All right. And now you can calculate the bias as a percentage of the tolerance. Tolerance is plus minus 0.25. So what is the total tolerance? 0.5. So 0.0051 compared against 0.5 makes me understand that the error is 1% of the working range. 1% is okay. Isn't it? Up to
Yes, sir.
10% is acceptable, right? But somehow if we can minimize. Otherwise, nothing wrong with keeping an error of 1%. Hope this is clear. How to conduct the gauge R&R study and then how to conduct the study.
Bias.
If there is a problem with the bias, the solution is calibration.
Calibration.
There's a problem with the bias, the solution is calibration. Now, I also want all of you to understand a little bit about the statistics. You all have yesterday understood normal distribution, isn't it?
Yes, sir.
Right? Now, little bit about statistics. First of all, statistics is nothing but, dealing with the data. Dealing with the data is known as statistics. What we normally do in a project, we collect data and then we tabulate it and then we visualize it and then we analyze it, and after analysis we interpret it, and finally after the interpretation we take the decision. Am I correct? The whole set of activity is known as statistics. So statistics is nothing but the science of collecting,
Organize.
organizing, presenting, analyzing, and interpreting the data. And the purpose is to make
Making
effective decisions. Effective decision means correct decisions. If you are using data, still your decisions are going wrong. Why is it going wrong? Because there is a lack of accuracy in the data. Yes or no?
Yes, sir.
That is why we have taught you something. Gage under study and bias to ensure the accuracy in the data. And now, once the data is accurate or clean and credible, you can use the data and you can calculate whatever you want to calculate. So statistics helps us to summarize any amount of data with a central value. What is the central value? Average. For continuous data, the central value is average. For discrete data, we normally use the statistics known as proportion. All right. And another thing is statistics also helps us to assess the degree of variation. Statistics also helps us to assess the degree of variation. Say, for example, this is our evening batch of green belts, right? We also have another batch of green belt. I want to compare which set of participants are performing well, whether the evening batch is performing well or the day batch is performing well. Can I use some statistics now to make a comparison? Same training,
Yes.
same examination, same trainers. And now I will compare the average mark scored by the evening batch against the average mark scored by the day batch. Is my comparison wise? I'm using the same statistics, isn't it? And then, suppose if the average is same, does it mean the both batches are performing at the same level? Still, there can be a difference,
Yes.
right? Because individual marks can differ, yes or no?
Yes, sir.
What will I do is, I will try to understand the spread of the data in the evening batch. I will also try to understand the spread of the data in day batch. Let's say in the spread of the data is too much. What does it mean?
Too
What does
much
it
of
mean?
variation, less consistency.
Too much variation. There are some students who score very low marks and there are some students who score very high marks. Whereas in the evening, everybody is scoring, very close to each other. I can see a higher level of consistency in the evening batch, which is also an indication of good control over my process. Yes or no?
Yes,
If
sir.
all of you perform in the same manner, then I can attribute this performance to our training. If some of you are performing extremely well and some of you are performing extremely bad, now how can I give the credit to the trainers here? Isn't it? So how much control you have over the process can be understood by studying or assessing the degree of variation. Variation can be studied with the help of statistical tools known as range, standard deviation, or variance. Whichever is best for you, you can use it. You all know the meaning of range, am I right?
Yes.
Maximum minus minimum.
In max
You all
minus
know the
minimum.
meaning of standard deviation. There is a formula, square root of summation of x minus x bar the whole
X
square
minus
divided by n minus 1. Yesterday we spoke enough. Yes, standard deviation. Now what is variance? Can somebody answer this question? Is there a way to calculate variance from the standard deviation? Come on. Yesterday we discussed. If I square the standard deviation, what will happen? That will become the variance. The squared value of standard deviation is known as variance. Clear, all of you?
Mm.
Let me say the standard deviation is 3. What will be the value of variance?
9.
That's all. Let me say the variance is equal to 16. What will be the value of standard deviation?
156.
No, no, no.
Sorry?
Variance
Okay,
is
4.
16. Variance is
4.
16, so
4.
standard deviation is 4.
4.
So which means if standard deviation is known, you can derive variance. If variance is known, you can derive standard deviation.
Standard deviation.
And also, there is one more relationship between range and standard deviation. This also will be helpful sometimes. Range equal to 6 times sigma. Range is equal to
6
6
times sigma.
times sigma. 6 sigma. That's why we always, keep 3 sigma on the right side, 3 sigma on the left side. Because the right side we go up to maximum, left side we go up to minimum. So the range is equal to how much? 6 sigma.
6.
So far good, all of you?
Yes.
Very good. And now I am studying about the kind of vehicles that are crossing a signal point in my area. I do this study for about 30 days and I come out with some conclusion. So the conclusion is there are 1,300 passenger cars are passing the signal point in 1 hour time, because always I study for 1 hour, right? And number of public vehicles 600, 2 and 3 wheeler 1,050, right? And this is what is known as statistics, isn't it? I did a survey, I generated data, and then after generating the data, I tabulated, I organized the data, and then I presented it. And see here, I made some graphs, and then I calculated some statistics. Can you see here? 90 days time, so many vehicles, and I have interpreted here. There are about 3,000 vehicles, 45% of them are passenger cars, 20% of them are public vehicles, 35% of them are 2 and 3 wheeler. This is known as statistics. So data helps in understanding what's happening in our study or what's happening in our process. And now statistics can be of 2 types. One is known as descriptive, the other one is known as inferential. What is descriptive? If you write your observation in the as it is condition, like here in the example, how many vehicles are crossing the signal point, what percentage are 2 wheeler, what percentage are 3 wheeler, etc., etc. If you write your observation in the as it is condition, it is known as descriptive statistics. Say for example, how many participants are attending the class today? 16 people, right? Including me, including the trainers, there are 16 people. Out of the 16 people, 4 people are attending the session on video, and remaining 11 people are attending the session of the video. All right. So this is the statistics. What am I doing? I'm just describing what's exactly happening right now in the training program. Yes or no? I'm generating some numbers which is helping you to document my observation. If I document all my observation with some numbers, with some calculated values, that is known as descriptive statistics. Clear, all of you? All right. Right. Suppose since there are traffic is too much here, if I construct a bridge, what will be the benefits? What will be the benefit? Right now, people are taking so much time to cross this particular signal. But once the flyover is constructed, then people can travel fast. Yes or no?
Yes.
Yes.
Within how many minutes they can cross that particular road? Some estimate you can make. How many
Correct.
people how many people in the locality will get benefited? Some estimation you can make. How are you making all this estimation? Where is the base value? The base value is your study. Yes or no?
Yes, sir.
Your descriptive statistics becomes the basis for your estimations and for
inferences.
your predictions. If you use your available data to estimate something or to predict something, then your statistics is known as inferential statistics. Clear, all of you? The statistics is widely used in all business. Your forecasting, isn't it? Sales forecasting and demand forecasting, and all of these things are statistics, right? And in Six Sigma projects also, statistics plays an important role. All right. And now look at my slide and tell me, is it descriptive statistics or inferential?
Descriptive.
Yeah. We all observed Virat Kohli's performance in 31 World Cup matches, and as it is,
Average
what
is
are the
50.
statistics used here? Average is used.
Average is 55.36.
That means the run scored by Virat Kohli is considered as a continuous data.
Correct.
All right. And highest score is how much?
107 maximum.
And how many centuries?
Third.
3 centuries.
And half
9
centuries?
centuries.
9.
This is
Nine.
called descriptive statistics. Somebody looking at these number can immediately understand what caliber of player Virat Kohli is. He is a very consistent performer. Yes or no?
Yes, sir.
Yes.
Very good. In 31 matches, maintaining an average of 55 and all of these things. But one thing is missing here. Can you understand? One information is not written here. His maximum is given, but the minimum is not given.
Minimum is not there.
So actually, as a statistician, for us, that minimum is also important, so that we can better understand Virat
Range.
Kohli, isn't it? Yeah, very good. And now what is this one called?
Inferential statistics.
Inferential.
Yeah, the match is still not over, but
Yes.
even at the stage, with the current conditions, current observation, they are predicting that India, the chance of India
Forecasting.
winning the match is higher. This is inferential statistics. And now I'm showing some images. The first image, look at the first image. And now what is this graph indicating? They call it hawk's eye, right? Hawk's eye, yeah, what is it? Yeah, the ball movement, right? DRS system.
DRS.
So the path followed by the ball is captured,
Is in line with
and
the
now they are checking whether the ball is hitting the wickets or not. Am I right?
Yes, sir.
And
With
now
line with this.
here, the white color line is descriptive statistics.
Okay.
The actual path followed by the ball. Actually, what happened here, the ball has hit the batsman's pad. But if the ball is allowed to travel further, in which direction it will travel? Simply you extend the line.
Towards the wicket.
Because the descriptive statistics is now
Towards the
helping us to
stance.
draw the blue color line. And by extending this line, we could easily judge whether the ball will hit the wickets or not. And now the third umpire makes a more effective decision with the help of these, statistical idea, which the umpire standing in the field cannot, sometimes struggle to make, isn't it? But the umpire sitting in the cabin with the use of the technology and with the use of the accurate information, with the use of the accurate data, he could make a decision more effective than a human umpire standing in the field. Agreed or not?
Yes.
Very good. So the secret is quality of the data, isn't it?
Mm.
That's why they kept so many cameras to capture the white color line, isn't it? Or the important characteristics of the white color line becomes the input for the blue color line. The entire line,
Correct.
the white and blue line, this is known as regression line. This is known as regression line.
Regression.
Nothing but mathematical model of the path followed by the ball. What is that? Mathematical model of the path followed by the line. Now tell me, is this line followed by the ball? Is it a straight line or a curved line? The path followed by the line, is it just a straight line or a curved line?
Straight.
It looks, actually it is not straight, isn't it? Can you see
Curved
here?
line.
Can you see here? It's a curved line. A curved line will have a separate equation and a straight line will have a separate equation. All of you have studied this in your schooling.
Yes.
Y equal to mx plus v means perfect straight
Linear.
line. Linear.
Focus
Y
linear.
equal to mx squared plus c means non-linear. Curved
Non-linear.
line. So
Geometry.
curved means square and cube will come. Straight line means no square, no cube,
square.
only x will come. All of you are with me?
Yes.
Yes.
Very good, very good. So with the help of the data, you can actually make very effective decision. That is why we are concerned about the data. Now you calculate, now you collect data, and then you collect data, and then you what do you call? Use the data, calculate whatever you calculate using the data. All the calculated values are known as statistics. Average is a statistics, proportion is a statistics, range is a statistics, isn't it? Standard deviation is a statistics. Anything you calculate. Let us say I simply square every data and then add all of them. That is known as another statistics. That is given a name, sum of squares. Why am I doing all of this? Because every piece of calculation is carrying some information in it. If I have the knack of using them wisely, I can interpret the information. The numbers can give information. Numbers can be used to calculate some statistics. These statistics will carry some information. If I can collect that information correctly, I can make more effective decision. Clear? But if I am not very careful enough in capturing the data, then what will happen? I might end up in making wrong decision. Even the DRS system will be helpless. Now in the DRS example, what is the output? The output is the path followed by the ball, what you are seeing here, isn't it? This is generated by a computer.
Yes.
For the computer to generate this line,
Curve.
it needs a mathematical formula, yes or no?
Yes.
That mathematical formula is what we have taught you as y equal to f of x. Now y is the line you are seeing in white and blue color. What are the x? What are the input needed to draw these lines? Can somebody tell me what are the input needed?
All lines.
Sir,
The speed in which ball has been bowled.
Ball.
Am I right? First input.
Hmm.
The speed of the ball is important.
The distance
correct or
till
not?
where it goes and touches the ground.
Yeah, the point at which the ball is pitching on the ground. Isn't it? The ball at which the point at which the ball is pitching, that point is also important. See here, this point. Pitch condition is another input. There can be different types of pitch. Accordingly, the bouncing level will vary, isn't it? Pitch condition. And the angle
wind
in which the
velocity of the
bowler has
wind.
released the ball. The angle in which the bowler has released the ball. The position
Speed
in
of the
which the
wind.
bowler has the bowler come again, ma'am.
Speed of the wind or air. I mean the speed.
Speed, yeah, wind,
Velocity of the wind.
wind speed. But please note, not all the factors are significant. If the speed of the wind is a significant factor, then you must have an instrument to capture the wind speed also, and that should go to your system also, and then the system will generate the equation. The moment you realize it is not significant, you don't have to worry, you don't have to capture. Say for example, the color of the t-shirt the bowler is wearing. Is it an important factor? No, that's not an important factor. The distance at which the keeper is standing, is it an important factor? No, that's not an important factor. All these inputs are insignificant. I don't need it. But the speed in which the bowler has bowled the ball, the angle at which the ball is released, the place at which the ball has pitched the ground, these are all significant factors. If I can have accurate measurement of these x values, I can get my y value in an accurate manner. That is what you are seeing on the screen. Clear? This is what people call it, the modern technology. But the basis is data. Can you see that? Without data, no technology can function. Your AI, your IoT, your robotics, your machine learning, everything, will give rubbish results if the data given to them is of poor quality. That's why very, very important. What's very, very important is accuracy of the data. Clear, all of you? So I would like to stop here for
Yes.
the measure, here, as far as the measure phase is concerned, but still we have one more tool to be discussed that I will discuss later on, right? So, but already you all studied baseline, some tools. Can you tell me what are the tools you already studied in baseline? You all studied DPMO, am I right?
DPMO.
What does it, can one of you expand it?
Defects per million.
Defects per
opportunities.
million.
Opportunity.
Million
Defects
opportunities. And PPM, you must be knowing. What does PPM
Parts.
stands for?
Parts
Parts
per
per
million.
million.
Parts per million.
Parts per million. Suppose if I say DPHU, what does it mean? This is a new tool. We have not
Defects
taught
per
you. Defects per 100 units.
100 units.
Defects per 100 units. I can also introduce one more tool, DPTU.
1000 units.
1000.
Defects per
Very good.
1000
That's
units.
all. Very good. Now you have become very smart, right? So as long as you know the meaning of the tools, you can use it in your process and you can understand something out of it. And if it is very relevant, please use it. If it is irrelevant, don't use it. All of them gives the same information, isn't it? And similarly, yield also you all learned. There are three
Right.
types of yield.
Three types of build.
One is traditional yield. Am I right?
Traditional. Correct, sir.
Yes.
Another one is
First
Another
pass
one is
yield,
first
When-
pass yield.
First fast yield.
And the third one is
rolled throughput
Rolled.
yield,
rolled
Third.
throughput yield. I hope all of you know the difference, right? Which is the best?
first
First
pass
pass
yield.
yield.
First.
First pass yield is best, but when you have multiple process connected, rolled throughput yield you must
Rolled
calculate.
through.
All rolled throughput yield is nothing but overall yield.
Overall
The
yield for all
the number of
boundary machine.
acceptable output at the final stage divided by the inputs at the initial stage. Number of acceptable outputs at the final stage divided by number of inputs at the initial
inputs.
stage. There is a difference between first pass yield and traditional yield. Traditional yield, the formula is acceptable outputs divided by input. Acceptable output divided by input. 100 people write the exam, 90 people have passed the exam. Now what is your yield? 90%.
90%.
Yes or no? But now I realize out of the 90 people, 30 people cleared the exam in the second attempt only. They have not passed in the first attempt. Now what do I understand? Only 60 people have passed the exam in the first attempt. Now what is my first pass yield now?
60%.
60.
Earlier I thought the pass percentage is 90%. I was feeling great. But actually what happened is only 60% have passed in the first attempt. So which one reflects the real capability of your process? First pass yield or
First
the
pass
yield.
traditional yield?
First
First pass
pass.
yield. First pass yield.
Understand the plus and minus of your metric and use it wisely. All right. If you want to make a presentation about your performance, probably you can use traditional yield. But if you are assessing the performance of others, ask for the first pass yield.
First pass.
Use it wisely, right? depending on the requirement. Yeah. So that's how it is. But if you know the meaning, yes, I know you will use it wisely, right? When to use the traditional yield. Suppose if there is an audit, then you don't have to show all the problems. Rather, you can show all your
Correct.
strength, right?
Correct.
But if you want to do a self-assessment, you want to understand your real capability, then use the right metrics.
Correct.
So in the next class, I will teach you CP and CPK, and which
Process
the
capability.
basics of which we already learned yesterday.
Yeah.
All right. So what I'm going to do is I'm going to hand over the session to Mr. Veer Raghavan. Maybe you all can quickly have a small break, a short
10
break. Just move out from your place and then come back in 5
10
minutes. Is that okay?
10
Okay,
minutes.
10 minutes. Okay, Veer Raghavan sir. They'll be back in 10 minutes time and you can slightly stretch it, right, if needed. Right, sir, you can proceed with your topic. And for the information of the participants, already we have taught you the introduction about the analyze space, isn't it?
Yeah.
Now we want to teach you some advanced tools. So that's why I've been demanding your effective participation, right? Otherwise, we can't easily teach all of this. Even we will be bored while teaching, to people who are not really, showing the participation. All right. So after 10 minutes, Veeraraghvan sir will take you through some advanced tools.
Okay.
Thank you, sir.
For 98, 80 is output. What is the first pass yield? Similarly, first pass yield for C you can calculate. And multiply all these three. First pass yield of A multiplied by B multiplied by C. What you are getting, that is the final figure.
Okay.
Okay.
But step B ka output should be less than 80, right?
Should be 80 or less than 80.
Okay.
Should be
So
less than or equal to 80. Not be more than 80.
we are not concerned with the scrap thing. We just have to see the rework and the output.
Yes.
Okay.
80 is the output. 80 is the output. Whether you rework or first pass it is coming, 80 is the output. So 80 should be input for B.
Okay.
Okay. Clear?
Thank you, sir.
So any other doubts? You can go to analyze phase. I think analyze phase you had a introduction already. Okay. So what is the outcome of what is the deliverable of measure phase? What is the output of measure phase? Baseline performance. Please have more interaction, please. Okay. Then only I will be able to. So baseline performance is the output of or deliverable of measure phase. Okay. The analyze phase, what we are trying to do is drilling down to potential critical factors. Okay. First step is listing of possible X factors. That is brainstorming and YO analysis. We are listing out these are all the potential causes or probably causes. Okay. That is only opinion. What is brainstorming or YO analysis? It is opinion of various team members. Correct?
Correct, sir.
It is just opinion. Okay, that we have to substantiate with some experimentation.
Yes,
Clear? So that is called hypothesis testing. Okay, that is where we are going to analyze all these X's, forming a hypothesis, and we conclude these causes are valid or invalid. Clear? Able to
Yes,
understand? Here, in this brainstorming and YY analysis, it is based on our pure expert opinion or based on team's experience. We have drilled down to some causes. Now, further we are going to do experimentation statistically, then prove these are all the causes, these are all not causes. That is called hypothesis testing. Okay. So let us go to hypothesis. Give me a second. Okay. So this is what is hypothesis first of all? We call it a statement. Okay. We call it a statement. There are two categories. Null and alternate hypothesis. What is null hypothesis?
The negative statement.
Negative statement. Okay. See, null and alternate hypotheses are helping us to validate the root cause. Okay. See, there are two groups. For example, there are two groups. Which group is contributing to more? Which group is contributing less to our problem? If you want to differentiate, which is significant, so we have to do hypothesis testing. Okay. Validate the root cause and difference, whether there is a significant difference or not between two groups or three groups. Okay, difference is to be a difference must make a difference. A difference to be a difference must make a difference. Okay. So we have analyzed and found out some causes using fishbone diagram and brainstorming all these tools. Okay. Now through hypothesis testing, we are going to substantiate those causes. Okay. Whether, for example, there are two set of machines. Two machines are there in your factory. Okay. Whether two machines, the output of two machines are in the same quality level or not. That we are going to differentiate. Okay. Null hypothesis will always say two machines produce equal quality. If it is two machines or three machines or even 10 machines, all 10 machines produce equal quality. Quality of parts produced is same in all the machines. That is called null hypothesis. They understand. And for example, one more case example is there are three suppliers for raw material. Okay, you are getting raw material from three suppliers. Generally, we will not depend on one supplier. We have 3 or 4 suppliers depending on the volume. Okay, these three suppliers, our null hypothesis will say these three suppliers are same performance. Whether it is quality or delivery or cost, it is same performance. Here we will talk more about quality. Okay, so this is the null hypothesis. Clear? There is no difference. No All are same. That is called null hypothesis. Clear? Alternate hypothesis, there is a difference. Between three suppliers, there are differences. All three suppliers are not same. That is called null hypothesis. Alternate hypothesis. Null hypothesis will say all are same. Alternate hypothesis will say all are different. Clear? Do you understand? So hypothesis testing is a claim about the difference between two or more groups, and it's tested for trueness in real life. Okay. There are two groups, two machines, two suppliers. For example, both the groups are performing same. For example, you have two batches, green belt batch. Okay. Both the null hypothesis will say both the groups are performing to the same level. Performance are same for both the groups. That is called null hypothesis. If I want to prove that both the groups are not same, they are not equal. One group is better than, the group 1 is better than group 2, for example. So I have to prove with some experimentation. I have to collect data and prove with some experimentation. That is called alternate hypothesis. Otherwise, I have to assume both groups are same. If I am not able to prove the difference, that means both the groups are same performance. Understand? Clear?
Yes, sir.
Okay. So null hypothesis, initial claim specified using common knowledge. Okay, common knowledge, because no impact, equality, no change, no difference. To be assumed if you cannot reject it. There is no impact. This cause is not impacting your problem. This particular cause is not affecting the results. These three suppliers are not are equal in terms of quality performance, equality. Okay, there is no impact, all are equal, no change, no difference. That is called null hypothesis based on common knowledge or existing practice. Okay, if you want to prove this null hypothesis is invalid, null hypothesis is false, if you want to prove that, you have to do some experimentation, correct? You have to conduct some experimentation. That is called alternate hypothesis. We also refer to as research hypothesis, because you are collecting some data and trying to prove that null hypothesis is no more valid. That is called alternate hypothesis. Statement of there is an impact, there is inequality between suppliers, for example, there is a change, there is difference. So two groups are performing in different manner. That is called alternate hypothesis. Batch 1, batch 2 of green belt, both are not same. Performance is not same. That is called alternate hypothesis. If you say performance are same, that is called null hypothesis. Clear? For example, you are
Yes.
trying to introduce for example, a new tool in your manufacturing line, new machines or a kind of new equipment you are trying to introduce. Okay. First, null hypothesis will say old equipment and new equipment are same. There is no difference. There will not be any difference in quality of product produced. That is called null hypothesis. Clear? Old tools and old new tools, both are same. There is no difference. That is called null hypothesis. But if you want to prove it, you have to collect data with the new tool or new equipment, then substantiate. There is a significant difference between these two, old and new. Then you are rejecting the null hypothesis. So null hypothesis generally called H0. This H0 is null hypothesis. Alternate hypothesis is denoted by H1 or HA generally. Clear? So we understood null hypothesis is no impact, no difference, no change, all are equal. Null hypothesis, correct? Alternate hypothesis exact opposite. There is a there is a change, there is a difference, all are not equal. Alternate hypothesis. So can we classify this? High pouring temperature will increase porosity. Whether it is null hypothesis or alternate hypothesis.
Alternate.
Why it is alternate?
Sir,
Why it is
because
alternate?
because
Please.
high pouring temperature is increasing the porosity, so it has an effect.
It has an impact. Very good word. Okay, you clearly understood that it shows it has an impact. It is showing it has an impact. That is called alternate hypothesis. Clear? Whether pouring temperature is impacting porosity, you are writing that is called alternate hypothesis. Calorie consumption will affect weight gain. What is this? Null hypothesis or alternate hypothesis?
Alternate.
Alternate.
Alternate, because again it is impacting the
Weight
weight
gain.
gain. Speed of the car will affect its mileage.
Alternate.
Alternate.
It is impact. Reaction time affects the process. Very good.
Alternate.
Alternate. So are able to understand?
Yes, sir.
This is statement of impact. What you studied is statement of impact. Let's see the opposite of this. That is called null hypothesis. Clear? Understand? Pouring temperature, no impact on porosity. So first
Null
you have to define what
hypothesis.
is your null hypothesis. First you have to define what is the null hypothesis.
Null
Then we have
hypothesis.
to do experiment. Then we have to do experimentation to prove that null hypothesis is not valid. Null hypothesis is false. For that only you are collecting data and do experimentation. That is called hypothesis testing. Okay. Clear?
Clear, sir.
See, in a court case, for example, okay, in a court case, you are accusing a person of
Connection loss, huh?
So you're not audible.
Yeah, some network issue.
Some
So
network
before
issue.
he joins, all of you, do you understand the context of hypothesis testing? When hypothesis testing is needed?
Yes.
When hypothesis testing is needed, tell me.
Means when you
When
want to bring about some change, so therefore at that time you will first make a statement which may be the null hypothesis, then you do experiment to prove it otherwise, and then go ahead to do the alternate or find the impact of the alternate hypothesis.
Excellent, excellent,
Sir,
excellent.
when we are finding the root causes, like what are the potential root causes, so how they are impacting the actual process, that is why we are doing the hypothesis testing.
Very good, very good. That is, hypothesis testing is needed when you are in doubt, when you are in dilemma. Am I right? When, see, during the root cause analysis, you conduct brainstorming discussion, isn't it?
Mm.
And then you plot a cause and effect diagram. Then you go for the impact control matrix. And now after doing all this exercise with some opinions, isn't it? If some of the opinions are really correct, what will you do? You implement, isn't it?
Yes, change your
If
strategy or implement
if
accordingly.
opinions are wrong, then you reject those opinions, isn't it?
Yes, sir.
Yes.
But whatever opinions you are in doubt, all of them will qualify for hypothesis testing. Clear? It is
Yes.
a claim validation procedure, whether the statement is correct or not. So you need to know what is a statement. Statement means here we call it hypothesis. There is null hypothesis, there is alternate hypothesis. There is a specific way you must write the null, which Sir has explained. There is a specific way you must write the alternate, which has been right now explained to you. This is a globally followed procedure to validate, I mean, to what do you call, yes, to validate the hypothesis. whether the hypothesis should be accepted or rejected. This is a procedure. That is why, all the terminologies are brought to you. Yes, sir, you can continue by sharing the screen. I think screen
There is a
sharing is,
network issue.
yeah, you got disconnected.
Yeah, there's a network issue. Looking at null alternate hypothesis. Okay, I was explaining with example in a court case. For example, you are accusing a person he has stolen some money. Okay, first you have to claim him to be innocent. First claim is he is innocent. That is called null hypothesis. Clear? He is innocent. Innocent. That means he has not stolen any money. That is called null hypothesis. Then what public prosecutor will do? He will collect a lot of evidence. He will investigate, do investigation. He will try to prove otherwise. He will try to prove a lot of evidence that he has stolen the money. Correct? So now you are claiming him to be guilty. That means null hypothesis is rejected. Clear? Are you able to correlate? Unless
Yes, sir.
until you prove with alternate hypothesis, null hypothesis is valid. Unless until you prove with the proper data, with experimentation, with proper evidence, you have to release him as innocent only. If you are not able to prove with the proper data, you will release him as innocent. He is not guilty. Clear? He is innocent unless until he is proved guilty. Same thing is applied here. Null hypothesis will stand as true as long as you are not able to prove his invalidity with the proper experimentation. Okay. So these are alternate null hypothesis. Statement of no impact. Reaction time has no impact on process yield. Speed of the car, no impact on mileage. So this is null hypothesis. We'll start our experimentation with defining what is null hypothesis. There is no difference between two groups or two machines or two batches. There is no difference. That's what first we will define this. And we have to prove with the proper data that it is invalid. So this is one more example. Supplier 1 deliver faster than supplier 2. This is null hypothesis or alternate hypothesis?
Null hypothesis.
How it is null hypothesis?
Alternate.
How it is null?
Alternate, because there is an impact.
It is
Because
not
there is no
impact.
impact.
Statement of equality. And supplier 1 is not equal to supplier 2. Delivery time of supplier is
Different from
not
that
equal
of
to delivery
supplier.
time of supplier. So it is statement of inequality. Inequality means
Alternate.
alternate hypothesis. Okay. Machine 1 produces parts faster than machine 2.
Alternate.
So the alternate. Okay, for statement 2, can we define null hypothesis? What is null hypothesis?
Machine 1 and machine 2 produce the same produce parts at the same speed.
Exactly. That's all. Speed of machine 1 is equal to speed of machine 2.
So you are
Null
frozen.
hypothesis. Understand? Polling rate of northern regions. Okay. Statement of equality.
There some is it a
Is there a problem again with the video?
Yes.
Again, there is a problem.
Yes, sir.
Okay. So no problem. So what is your understanding so far? That is very clear, right? When you are in doubt, you need to perform hypothesis testing. So what is hypothesis testing? An experimental procedure, am I right?
Yes, sir.
An experimental procedure. At the end of the experiment, we'll take a decision. At the end of the experiment, we'll take a decision whether the claim made by the project team is correct or not. All right? Yes, okay. So always please note in hypothesis testing, we make decision on the null hypothesis. We make decision on the null hypothesis. Either we reject the null hypothesis or what is the opposite? We reject the null hypothesis or we
Accept.
fail to reject the null hypothesis. Either we reject the null hypothesis or we fail to reject the null
Fail to
hypothesis.
accept.
So what is the meaning of rejecting null hypothesis? What is the meaning of rejecting null hypothesis? And before we try to understand what is the meaning of rejecting null hypothesis, there is a saying by Benjamin Franklin. You all know Benjamin Franklin, right? He says, a new truth is a truth.
It's a truth till it is proved otherwise.
An old error is an error. All right? So normally, in our context, hypothesis testing is nothing but the old belief or the old knowledge. The alternate hypothesis is nothing but the new knowledge gained from the experiment. Right? The new knowledge gained from the experiment is normally alternate hypothesis. Already existing knowledge, already the believed knowledge by the company is the null hypothesis. All of you understand? Certain statement you are doubtful. Let's say pouring temperature is critical to the porosity. So far, your company never thought that pouring temperature can be a root cause of porosity, isn't it? So what is the old knowledge there? Pouring temperature is not critical to porosity. Like the color of the t-shirt the bowler is wearing is not critical to the direction of the ball. Isn't it? Same manner, your company believed that the pouring temperature is not critical to porosity. If you write in this manner, that is known as null or alternate.
Null hypothesis.
Yeah, if you say no critical,
Null.
no impact, then it is null. Then what is alternate? Pouring temperature
is
is critical to porosity.
affecting the
We come to the side of the alternate only when the null is rejected. Because so far your company is believing that pouring temperature is not critical to porosity. First of all, you must make your company, understand that their belief is wrong. Am I right?
yes.
That is known as rejection of null hypothesis.
Hmm.
Unless and until you make people realize that their belief is wrong, how are they going to listen to you on the further information, isn't it?
Correct.
So the first step is reject the null. If you can convince people to reject their null, if you can convince people to, accept that their belief is wrong, further it will be easier for you to make them believe on your alternate. Am I right?
Yes.
All right. So this is how hypothesis testing must be conducted. The concept is little confusing. But if you deep dive, later you realize it is nothing. All right? Why do I say it is nothing? Finally, you are making only one decision, whether my experiment is valid or not. That's all.
Along.
If my experiment is valid, I will take a decision and then make some changes in my process. Do you understand? If my experiment is valid, I will use my new knowledge and then I may make some changes in the process using the new knowledge. But what kind of changes? You have to use your common sense. That hypothesis testing will not tell. Suppose if my experiment is invalid, I just have to consider my experiment, insignificant. All the findings are considered insignificant. There itself, I will close the chapter. I will not do any changes. All of you, please note whether you are making the correct changes or not. You should never make a wrong change. Whether you are helping someone or not, you should never harm someone. Yes or no? These are the normal,
Basic
the
tenets.
globally practiced rules. You can allow 100 culprits to escape, but you should never punish one innocent. Yes or no?
Yes. Yes.
Same rules should be followed in hypothesis testing also. You are trying to make changes in a process. Never ever make an unnecessary change. Whether you make a necessary change or not, you are not supposed to make any unnecessary change. Do you understand? Some people, by saying that they will do improvement and etc., they will collapse their current result also. That should not be the case with you, right? So that's why you take your decision or you base your decision based on experiment. And so first you try to, you see to that whether you can reject the null or not. And for rejection of the null, there are certain tools, isn't it? You conduct an experiment and then you will study the impact. Now the doubt is whether the impact is significant or insignificant. Whether the impact is significant or insignificant. How do I know whether the impact is significant or insignificant? By looking at the difference, isn't it? All of you are attending the training program. Do you think the impact of the training program will be significant or insignificant?
Significant.
Significant. Let's say after becoming a green belt or a black belt, let's say you are getting, yes, 70% hike in the salary. The impact is significant or insignificant?
Significant.
Significant. Suppose you get only a very just 5,000 rupees increment. Do
Insignificant.
you think that is because of because of your knowledge, new knowledge you gained? Is that the company recognized your skill and then offered the increment? I am very much doubtful now. Isn't it? So the difference between your old value and new value. You have done some experiment with the old condition and with the new condition. And there is a difference between old and new. Is this difference significant or insignificant? Now, what is the rule to say that the difference is significant? That has to be understood, isn't it? In order to understand, we calculate some statistics. What do we calculate? We calculate some statistics. We all know continuous data means we calculate average. Discrete data means we calculate proportion. All right? Whether you calculate average or proportion or whatever, all of them, when you actually predict or estimate, there will be an interval. Yes or no? Say for Say for example, in Virat Kohli's case, what was his batting average? You read it in my slide, isn't it?
Yes.
55.
55
Does
Does it mean
55.
in every match he scores 55 runs?
55 runs.
55
No.
plus or minus. It is first of all, please note, it is not the score, the runs scored by Virat Kohli in a single match. It is the average of the runs scored by Virat Kohli.
107 matches. 31
Average,
matches.
you all know average, right?
31 matches.
We are now,
31 matches.
now you can predict the average. Predict the average means in the next series of matches, let's say 10 matches, what will be the batting average of Virat Kohli? Because predicting average can be, better. The interval of predicting an average can be better than interval of predicting a single observation. The next match, what will be the score, run scored by Virat Kohli? He may score 100 also, he may get duck out also. I don't know. Isn't it? Predicting individual observation is very difficult. Do you understand? But predicting average is easier, which means it is predictable. So imagine Virat Kohli's batting average is 55. So in the next series of matches, Virat Kohli will be playing. What will be his average? 55 plus or minus some runs. Am I right? Come on, yeah, all of you have to speak
Yes,
out.
sir.
Yes, sir.
If you are not going
Yes,
to
sir.
speak out, I will stop speaking. So 55
No,
plus or minus some runs. that plus or minus some runs, that is known as margin of error. That is known as margin of
Margin of
error.
error.
How to calculate margin of error? Margin of error is nothing but 2 times standard error. What is the formula? Margin of error is known as, margin of error can be calculated using the formula 2 times
2
standard
times
error.
ST.
What is then standard error? How many World Cup matches Virat Kohli played?
30 matches.
37
31.
matches, right?
31.
31 or 31 matches. And now imagine he got some 31 scores. Am I right? He got 31 score. Can you calculate a standard deviation using the 31 scores?
Yes.
Yes. Standard deviation is available. Standard error is nothing but standard deviation divided by square root of your sample size. In Virat Kohli's example, standard error is equal to standard deviation divided by square root of number of matches played, which is 31. All of you, now do you have a formula to find out standard error? Yes?
Yes.
Yes or no?
No.
Am I audible?
Yes, sir.
What did I explain now?
Yes, sir.
Standard error equal to standard deviation divided by square root of sample size. Clear? And this standard error, why am I bringing this new term standard error? Standard error will help you to find out the confidence limits for the average. What is the purpose of standard error? To find out confidence limits
confidence
for the
limits.
average. When I use plus or minus 2 times standard error, I will be able to get 95% confidence limits. Rule of normal distribution. You remember yesterday we learned, isn't it? 2 times error, 2 times standard deviation, the coverage will be 95%. Do you remember? How many of you remember now? All of you should remember, right? Then only you will be green belt or black belt. Okay. So plus or minus 2 times standard error. Now simply I am going to assume standard error, 2 times standard error is equal to 5 runs. 2 times standard error is equal to 5 runs, which means standard error is 2.5. 2 into 2.5 is how much? 5 runs.
5 runs.
Now please tell me what will be the value of average plus 2 times standard error for Virat Kohli. Average is how much?
55.
55 runs.
56.55.
2 times standard error is 2 into 2.5 is how much?
5.
5.
5 runs. So 55 plus 5?
60.
60.
60. So 60 is the upper confidence limit for Virat Kohli. Clear all of you?
Yes, sir.
Now,
Yes, sir.
now you please tell me what will be the lower confidence limit? 55 minus 2
Minus
times
5, that
standard
is
error. Now what will be the
50.
value?
50.
50.
50.
Now you know the
50.
confidence limits for the average. All of you are with me so far?
Yes, sir.
Now in your experiment, please listen to my statement very, very carefully. In your experiment, if your average falls outside the confidence limits, if your average falls outside the 95% confidence limit, you must consider the observation as significant. You must consider the findings in your experiment as significant. If the average falls within the confidence limits, you understand? Within the confidence limit, the experimental findings should be considered insignificant. All of you, please tell me, do you understand now? When do we say significant?
When it is outside when the average falls outside 95% of the confidence limit.
Exactly. Let's say the
That means it
same
will be
thing in
significant
a
at
different manner.
0.5, sir.
Let's say your current salary is 55,000 rupees a month, and normally in your company plus or minus plus 5,000 is the increment, right? Plus 5,000 is the increment. So everybody expect that the increment will be the next year salary will be 60,000 rupees.
60. Hmm.
But what happened? This year's performance was so impressive that company has offered you an increment, let's say 12,000 rupees.
Hmm.
Now, what is this telling you? Your performance is significantly better than
Significant.
average employees. Yes or no? An average
Hmm.
employee, they get an increment of only how much? 5,000 rupees.
5,000.
But why are you given 12,000 rupees? Because they could easily understand your performance is significantly higher than
Significant.
others. Yes or no?
Yes.
In statistics, you can use the word significance only if your statistics falls outside the expected
Outside
limit.
the 90%.
Falls outside the expected limit. Expected limit can be 95% confidence limit, or expected limit can be 99% confidence limit. You
99%.
can fix it according to your requirement. But general practice is 95% limit.
95%.
Which means, please note, which means there is 95% chances there for your statistics to fall inside the confidence limit. Is my language clear? All of you are able to
To fall
understand?
inside the confidence limit.
Yeah. There is 95% chances there. 95% chances there for our statistics to fall inside the confidence limits. Now, please tell me, please answer my question. Now, what percentage chance is there for my statistics to fall outside confidence limit?
5%.
Beautiful. This 5% is known as level of significance.
Level.
Now we really want to know whether our statistics is outside the, whether our statistics is inside the 5% region or inside the 95% region. All of you are with me on the statement so far and the discussion so far?
Yes, sir.
I just want to know whether my statistics is in the 5% region. The 5% region is known as zone of significance. 5% region is known as zone of significance. The 95% region is zone of insignificance. That is normally expected. Right? So, how can I know whether
Okay,
my
that is
statistics has
5.5.
moved out of the insignificant zone or whether my statistics has entered the zone of significance? There is a beautiful tool available in statistics. I'll tell the name of the tool. It is nothing but p-value. Please write it down. What is the name of the tool?
P-value.
P-value, which stands for probability of significance. Whenever you have a set of data, there is a method, there is a formula using which p-value can be calculated. Using which p-value can be calculated. Whenever you see your p-value lesser than 5%,
Less than 0.5.
whenever you see your p-value lesser than 0.05, it is a confirmation that your statistics has entered the zone of significance. Is my language understandable to everyone so far?
Sir, it should be if p-value is less than 0.5, no, not 0.05.
0.05, 0.05 means 5%.
Is for 95%. Okay.
0.05 means 5%.
Yeah,
Because
0.05.
p-value is
Right.
just a probability.
Hmm.
If p-value is less than 0.05, it's a confirmation that my statistics has entered into the zone of significance, which means my experimental finding. The experimental finding is a significant finding. Do you understand? The knowledge, the new knowledge I gained is significant. I just cannot ignore. Please understand. So what will I do is, with the gained knowledge, I go back and tell my company that the old belief is wrong. So I request my company to accept the change I am going to suggest. This is known as rejection of null hypothesis. If you are able to reject the null hypothesis, your hypothesis testing procedure is over. In case if the p-value is found to be more than 0.05, now what happened? You are not able to reject the null. You are not able to reject the null means don't take any action.
In change.
You're not supposed to take any action. You don't have to make any change under that condition. Whatever you observed in the experiment, that should be considered insignificant. Because we always want you to, the company always expect you to take the right decision, which again means if somebody conduct the same experiment which you performed, 95% of the time, the new person will also come to the same conclusion what you arrived. This is called a 95% confidence level. Isn't it? At least 95% of the time, if the experiment what you performed, if it is repeated 20 times, at least 19 times, people will come to the same conclusion. If this is not going to happen, then your experiment will not be considered for making any changes in the process. Clear, all of you? Have I explained it properly? So what is the first step? First step is frame the null hypothesis.
Mm.
Also alternate hypothesis. Right after framing the null and alternate, you have to fix on the level of significance. Step number 2, fix level of significance. Normal practice is 5%. All of you are with me? What is the first step?
Yes, sir.
Frame the hypothesis. What is step number 2? Fix the level of
Fix the
significance.
level of
Normally,
significance.
normal practice is 5%.
95%.
Now, step number 3, conduct the experiment. Collect the data about X and Y, where Y is the response, X are the factors. Y is the response, X is the predictor. You are just studying the X, whether X is having an impact on the Y or not. Right? And you conduct the experiment multiple times, calculate the average, and check whether your average is in the zone of significance or zone of insignificance. And you don't have to do anything. Simply calculate p-value. That is the easiest way. The easiest way and moreover the smartest way nowadays is calculating p-value. Again, the calculation also you don't have to do it manually. You can use Minitab. And if the and look at the p-value. If the p-value is less than 0.05, what is the conclusion? Reject
It is
null
statistically
hypothesis.
significant.
Reject
Not
the null
statistically
hypothesis
significant.
means the doubtful statement is a valid statement. That's all. And so a change must be effected. What kind of change you need to make? You think wisely and then implement. This is what is hypothesis testing. And now how can we do this with some example? I think we can go through now. I think Veer sir can do that maybe with the Minitab or with his slides. Sir, will you be able to take over from here?
Yes, sir.
Yeah. So just since you were on and off, so I just finished this part.
Thank you. Thank you, sir.
I suggest all of you to be participative, right? Otherwise, even the trainer will get confused with this topic. So don't
Yeah.
allow the trainer to get
It's
confused.
a very
You have
tricky topic.
make him active.
Uh,
Even
this-
I will also go confused while teaching the hypothesis testing. Normally, it's quite normal. But if all of you are very participative, then we can be more, alert and do it.
So I will
Oh,
cover type
screen
1 and
sharing.
type 2 error. Type 1, type 2 error not covered, no, sir?
For type 1, type 2 error, in the measurement error itself, I have explained them. Type 1, type 2 error, false positive, false negative. Please, all of you note, in hypothesis testing also, the same thing is possible. In hypothesis testing also, same thing is possible. You know what is that? If the null hypothesis is true, you still reject it. You know what will happen? That will lead to an error known as type 1 error. See, I told you in manufacturing,
positive.
the meaning of type 1 error is manufacturer's risk. Type 2 error is consumer risk. In medical field, type 1 error is false positive.
False
Type 2 error is false negative.
False negative.
In hypothesis testing, the meaning of type 1 error is rejecting a true null hypothesis is type 1 error. Accepting a false null hypothesis is type 2 error. We don't want to commit this error. Right? We don't want to commit this error. That's why always while rejecting the null hypothesis, we check for the p-value. P-value will let you understand the chance for your decision going wrong. The chance for your decision going wrong should be lesser than 5%, which also implies that the chance for your decision to hold good is 95%.
Sir, could you please repeat the part of type 1 when it comes to the null hypothesis? Can you just
Yeah,
repeat
when
that
it comes to
statement?
hypothesis testing, type 1 error means rejecting a true null hypothesis is known as type 1 error. Very simple. Rejecting a true null hypothesis. What does it mean? Your company's belief is wrong, but you are giving them unnecessary advice, which you are not supposed to do, which is not good for your career, isn't it? That's why you need to look at p-value. All right, sir. I think people have understood. Maybe you can cross-check by asking some questions. All the people, I think, will nicely answer now.
Yeah. Thank you, sir.
Okay, but I'm not able to see any reaction in the faces of the participants. Very serious. Those who are on video, they are very serious, and those who are not on video, I don't know whether they have slept.
So really, this topic is
Because
really
it is what we are talking right now with a nice dose of sleep. You can easily sleep.
sleep, but topic is also the subject is also that complicated bit. Null and alternate, so many combinations, difficult to understand, but a bit of concentration will be able to grasp the concept. Okay. So as we have seen, rejecting a good product based on sample size, that is called manufacturer risk. It's called manufacturing. You are rejecting a good product based on some sample size.
Yeah.
So you are at risk. You are wasting money. So manufacturer risk. Whereas the consumer is accepting a bad product. This is bad product. Customer is accepting
Consumer's risk.
product, that is called consumer risk. Okay, manufacturer risk is called alpha. Consumer risk is called beta.
Beta.
Okay. This is very relevant to manufacturing industry. But when you come to hypothesis testing, as Shivkumar sir has told, rejecting a true null hypothesis, that is called type 1 error. Rejecting a true null hypothesis. Null hypothesis is true, but you are rejecting it. That is called type 1 error. Can we say discuss one case? For example, there are 3 vendors for your company supplying some raw material. There are 3 vendors supplying raw materials. What is null hypothesis here in terms of quality?
All of them have the same quality, deliver the same quality.
Very good. Good understanding of null hypothesis. That is, all are equal in quality. They are supplying equal quality products. That is called null hypothesis. Okay. And what you are joining as a purchase head there, and you are doing some study. Okay. And you are telling vendor 1 is good at supplying quality products. Vendor 2 and 3 are not supplying quality products. With some 3 months data, you are analyzing and concluding vendor 1 is doing good. Vendor 2 and 3 are bad. So management is taking decision to stop contract with vendor 2 and 3, for example. And you are giving all contracts to vendor 1. Clear? So what you are trying to do here, you are rejecting the null hypothesis.
The hypothesis.
You have rejected the null hypothesis with a past data, proving that vendor 1 is not equal to vendor 2 and 3. Vendor 1 is different, vendor 2 and 3 are different. Clear? Alternate hypothesis, null hypothesis you have rejected, and alternate hypothesis you have proven. Based on that, management has taken decision to retain only one vendor, that is vendor 1, 2 and 3, they have stopped. Now after some time, after a month or so, vendor 1 is also poorly performing. Vendor 1 performance is also very poor. Quality is bad, as equal to vendor 2 and 3.
Correct.
Correct? You have, what is that? Then you have made a wrong decision. The purchase said you made a wrong decision. That means you have committed type 1 error. Understand?
Hmm.
You
Yes,
have made a type 1 error. Null hypothesis is true. null hypothesis is true. That is, all vendors are having equal quality. Okay, you have rejected the null hypothesis. So that is called type 1 error. Clear?
Type 1 error. Okay.
Yes.
Yes, sir.
Okay. And type 2 error. Similarly, if you are accepting a false null hypothesis, you are accepting as a good. See, for example, you are joining a company and company practices are not good. Very raw, some malpractices are happening, all these things. Okay, that is, you are accepting it because you are not able to prove. You are not able to prove that false practices are happening, you are not able to prove, then you are accepting it. That is called a type 2 error. Can we say false, null hypothesis is false, but you are accepting it. That is called type 2 error. Clear? You are able to
Yes,
correlate.
sir.
So this we have seen p-value, that is probability of significance. So when we will reject null hypothesis,
When the P is significant at 0.05.
p is significant. But no, when p is less than 0.05.
Sorry, P is less than 0.0.
When p, sorry, yes sir. So we are not able to hear you. Sir, Shivkumar sir, we are not able to hear.
Am I audible now?
Yes,
Yeah.
yes, sir. Yes,
Yeah,
sir.
yeah, yeah.
Yes, sir.
No, what I was suggesting is the first statement, if you look at p-value is the probability that the calculated statistics is equal to the observed value or beyond it. It actually means we are only checking whether my statistics has entered the significance zone or not. What is significant? The last 5% area is
95%.
significant, isn't it? The 95% is already expected, isn't it? The unexpected zone is significant zone.
5%.
My statistics has pushed beyond the expected level. So that is what is written in a diplomatic manner here. So you should not get confused by reading it. Is the probability that the calculated statistics is either equal to the observed value or beyond it,
Beyond.
right? So and p-value simply checks whether your statistics has entered the significant zone or not. If maybe if you imagine you achieve a p-value of 3%, what does it mean? You achieve a p-value of 3%, what does it mean?
It means that 97%
Okay, sir.
of the
You allow me just stop the screen for a while. I will share from my side so that I can write something.
Yes, sir.
Yeah, yeah. So I will share my screen and then show you this thing. But actually, deep understanding, if you understand, that's good. But otherwise, also please stick to our guidelines, and that is good enough. So you should be able to see my screen now. All right. Yeah. See here, I'm writing something here for you. Can you see my bell curve?
yes, sir.
Okay. Imagine up to this is 95%. And this area is 5%.
5%.
Yeah. So 95% also, 95% means that hatched area. 5% means unhatched area. Now please note, my statistics falls here. The statistics is nothing but average. Now the definition of p-value is the area beyond the observed value. That is what the slide was showing. Am I right?
Yes, sir.
And see here, this blue color area represents your p-value. Now, if you look at the statement given by Veeraraghavan sir, what he gave? The probability that the observed statistics is on the observed value or beyond it. Observed or beyond means on the right side.
Right side
Now,
observed.
please tell me, the blue color hatch area, will it be more than 5% or less than 5%?
Blue color hatched area.
I mean,
More,
this area,
5%.
this blue, I mean,
it will be more
all
than
the hatched area
5%.
right now.
Is more
Just
than
now I'm
5%.
hatching with,
More than
Is more
5%.
than 5%.
yeah, more than 5%. That's what I want you to know. And so in this scenario, you must consider that, the observation is insignificant. That means don't reject your null in this scenario. Because you confirmed me that, you just okay. What happened? Yeah. Why it is not writing? Let me share again. Yeah. Okay. So that means it is in this condition you are not supposed to reject the null. Clear, all of you? Why we are not rejecting the null? Because my p-value is more than 0.05.
More than
Suppose,
5%.
yeah. Suppose imagine if my curve is like this, and here this line is known as line of significance. Because if my statistics goes beyond this line, I can easily understand my statistics has entered the zone of significance, right? Now imagine this area, left side area, the area to the left of the line is 95%. Am I right?
Correct, sir.
The area
Yes.
to the right of the line is 5%.
5%.
Suppose if
5%.
it happens to see your statistics here. Now, please tell me what is the area to the right of your statistics? Will it be more than 5% or less than 5%?
Less than 5%.
Less than
Very
5%.
good. So from this, what do you understand? What is the definition of p-value? P-value is the probability that your statistics stays at the observed value or beyond it.
Beyond well.
This is the definition, and difficult to understand definition. But if you could understand, you straight away you stand out from other professionals. Isn't it? So now you can actually proceed with the slides. Sir, you want to show the slides, please? Now you can just cover it up. See, this is not that much complex, but the only thing is you must have a thorough understanding on the basics. What is confidence limit? What is significance zone? What is insignificant zone? And the purpose of the p-value and all of this. Okay, I think if all of you are okay with the concept, no questions, maybe one example we can see, can be discussed, and then we can, we can close for the day. Yes, Veera sir.
So this is one example for null hypothesis or hypothesis testing. So what is the null hypothesis? The cooking oil manufacturer claims that saturated fat content is only 15%. Okay, it is only 15%. What is the alternate hypothesis? It can be more than 15%.
More than 15 or less than 15.
It is not equal to 15%. This is called alternate hypothesis. Clear? So if you want to test this, there is a test name called one sample t test or one sample z test.
Mm.
If you are comparing the reference value is 15%. And you are trying to prove that saturated fat content is not 15%. That is called the one sample t test. Or one sample
So
z
this
test.
becomes the chi-test.
Chi-square, no, this is not chi-square test. This is one sample t test. Where we test the sample with respect to a reference value. Sample mean, this is test of means. You are taking a sample mean. The sample mean you are comparing with the reference value. That is 15% is the reference value. If you are comparing, trying to find out whether the difference is significant or not. Clear?
Yes.
Here, what is there? Two vendors serving a same company. Okay. Null hypothesis is transaction time for both the vendors are same. Transaction time is same for both the vendors. That is called null hypothesis. Alternate hypothesis, it is not equal. Either it is more than TI is more than TB or it is less than TB. So that this way, if you are trying to compare two groups or two populations and two samples, that is called two sample test. Clear? You are trying to compare two vendors or two groups, two samples, two batches. How two batches are performing, that is called two sample test. Next, if you want to study more than two vendors, transaction time of say 3 vendors, if you want to study,
Yes.
and the test, you have to conduct this ANOVA test. This is analysis of variance. Okay.
Mm.
Here we compare again. What we finally we see is p-value. P-value less than 0.05. We reject this null hypothesis. That is, transaction times are not same for all vendors. We reject this. If p-value is less than 0.05. If it is more than 0.05, what will do?
Then you will not reject the null hypothesis. You will accept it.
The null hypothesis. Null hypothesis valid, will not do any process changes. Clear? Able to understand? Want to recap anything here? We can do some exercises in the coming sessions on how to conduct one sample t-test or z-test. Both are almost the same. Some minor changes only. We can conduct a practical experiment in mini tabs in the coming sessions. Any questions here? You can clarify. Sir, Shivkumar sir, can we close or anything more we have to add here?
Yeah, so all of you understood the point right now explained about the selection of the test. What are the tests he mentioned right now? Come on.
One sample test
Am I
and
audible?
two
Yeah.
sample test.
Test, jet test,
One
ANOVA
sample
test,
t-test, two sample t-test,
ANOVA test.
and I think I
ANOVA test.
mentioned
ANOVA.
about ANOVA also, right?
Yeah.
ANOVA, right? Sir, you can stop sharing. You can stop sharing. Okay. Now imagine, now there are how many people here? There are about 15 people and let's say, okay, 15 people. So I divide this group, divide this set of participants into two groups. People who attended on video and people who attended the session of the video. Now I divided based on two groups. Yes or no? One group, let's say only, some half of the people attended the sessions on video and other half of the people attended the session of the video. Now I doubt. Our understanding is people who are on the video, they are very attentive. And so they participate well and so they gain more knowledge. This is our no doubt. We can be correct also, we can be wrong also. Yes or no?
Yes.
Right. And the other half, obviously, we expect that, their understanding will be less because they will not be interacting. And that is the thing. And now this is we are in a doubtful situation. Now we need to make a proper decision. Right? Now this leads to a scenario of hypothesis testing. Am I right?
Yeah.
Yes.
Now what do we do? In every training program, we make an observation of participants who are on the video. Right? Because we always conduct the exam, isn't it? We write down the marks scored by the participants who attended on the video. I have one side, I have the marks of people who are on video. On other side, I have the marks of people who are not on video. Clear?
Clear.
Yes or no? There are
Yes.
10 people on video and there are another 10 people not on video. Now I have 10 readings on the left side, 10 readings on the right side.
That's it.
Now I will take the average mark on the left side, people on video. Average mark on the right side, people not on video. Do you think both average will be same? Maybe
Yes.
different, maybe close
Or
to each
maybe
other.
same.
Am I right?
Yes, sir.
If there is a difference, I want to understand whether the difference is significant or not.
Mm.
Clear? If the difference is significant, then I will make a conclusion out of it. I will make a conclusion out of it. Now, what is the test I am doing right now? I am comparing two set of people. Am I right?
Yes.
I am comparing two set of people. And what is my experimental data? Test marks. Test mark is my experimental data. Am I right?
Yes.
And what is the statistics I am using? I am comparing the average. Yes or no? I am comparing the average. Now, what is the name of the study? What is the name of this hypothesis testing? There are two groups. My data type is continuous. The statistics use this average. And I want to understand whether the difference in the average is significant or not. This is the study. What is the name of this hypothesis testing? Two sample t
Two
test,
sample Z test.
not G test. T
T test.
test.
T test.
T test.
T test. Clear, all of you?
Yes, sir.
Suppose if I have three groups, group
In
number
our
one,
test.
group two, group number three. Now I want to study, I want to understand whether any particular group is able to perform significantly better than others. That is my doubt. That is my point. Maybe they might be using some extra techniques. I don't know. If the technique works, then I want everybody to follow the technique. Let's say one set of people, they are attending the session with the laptop. Other set of people attending the session with mobile
File.
phone, and one more set of people maybe with some other tech method. Now there are three groups. Now I want to understand whether any particular group, is performing significantly better. The moment I understand, yes, people who are attending the session with the laptop are able to significantly, perform significantly better. From next batch onwards, we'll make it compulsory for all the participants. But before making this change, we should first of all really be sure, isn't it? So I do the study again. Now three groups. First column, there are set of marks. Second column, set of mark. Third column, set of mark. First average, second average, third average. Now I have two options. One is I can study two groups at a time. When I study two groups at a time, this is known as two sample t test. But three tests will be required. I have to study A and B first,
A and B, B and
and
C,
then I have to
A and
study
C.
B and C, and then I have to study C and A. Every time I conduct experiment, experimental errors are possible, sampling errors are possible. So there is no point of conducting so many experiments. So I don't want to go for two sample t-tests 3 times. So I will simultaneously study all the three groups in one go. Do you understand the difference?
Yes.
Simultaneously, I conduct the test for all the three groups using one single question paper. That's all. No multiple question papers.
Correct.
ANOVA.
And what?
Analysis of variance.
Variance.
ANOVA means analysis of
Yes.
variance.
Analysis
Now
of variance.
the point is there are more than two groups. Can be three groups. Can be 10 groups.
10 groups.
The advantage is you will not have too much error in your data. Right? The error is minimized, and hence you can come out with a more effective decision. Now you understand the scenario for ANOVA. You also
Yes.
understand the scenario for two sample t-tests. Am I right?
Yes.
Yes, sir.
Let me ask a question. There are two suppliers supplying raw material to your company. All right? Both of them are supplying aluminum ingot. Both of them are supplying
Okay.
aluminum ingot. And now you want to buy the raw material, the aluminum ingot, from the supplier who meet your requirement of, let's say, the strength of the aluminum. The strength of the aluminum should be in a particular. The strength of the aluminum should be a particular range. Now, what do? You take
Two
sample from
sample
supplier
two.
1, take sample from supplier 2,
Supplier,
and send the sample
The
pieces to the
analysis.
laboratory.
supplier.
Calculate the strength. Readings will come. And similarly, supplier 2 readings will also come. His average is the average strength of supplier 1 is available. average strength of supplier 2 is available. Now you want more strength. So you will check whether which average is better. And definitely there will be difference in the average. But if the difference is not significant, you simply cancel the contract with the supplier. You are not, you are not having a proper practice, isn't it? So when you are selecting a supplier, you have to be very, very sure that the supplier you select really supplies the quality material. So for that, you have to check for the significance. Now, what is this study called when you are dealing with two suppliers?
Two sample t-test.
Good as
Yeah.
test.
Because there are two groups you are comparing, because the data type is continuous, because the statistics use this average, this confirms that your hypothesis test is two sample t-test. Clear?
Clear, sir.
Suppose you have only one supplier. You have only one supplier and your requirement is strength of the material should be a particular value. The strength should be a particular level. Let us say 400 Newton per mm squared is the required strength. You have a reference value and then you are just checking whether the supplier meets the reference or not. Now the study is known as one sample t-test.
One sample t-test.
All other conditions remain same. There is only one sample or one supplier. And what is the data type? Measurable data.
Measurable data.
So you take multiple sample and calculate the average. Again, the statistics use this average. The sample average is compared against the standard value. Clear, all of you?
Yes.
Yes, sir.
Now I ask another question. Do you think the supplier will allow you to access their complete data?
No.
He will not allow.
Correct.
Under such situation, you will perform one sample t-test only. Suppose if the supplier is okay to share all the information means all his production data. Earlier, only sample you got the access, isn't it?
Yes.
But in another scenario, the entire population data, the supplier is willing to share with you. All of you, do you know what is the meaning of population? What is the meaning of population?
All the entities that are.
Yeah, all the entities together is known as population. To the best of the ability, the supplier is producing for last 6 months. All 6 months data is available with the supplier. And that supplier says, sir, you give me the contract, I will share my complete data. Now you can perform a test known as one sample G test.
One sample t-test.
Do you understand the difference? When to go for G test and when to go for T test? Because G test means population data is required. Population data means population average and population standard deviation. If population information is not shared with you, particularly population standard deviation is not shared with you, you can't perform one sample G test. The average and standard deviation are like the horoscope. If I look at your horoscope, I could understand all your characteristics. Yes or no?
Yes.
Same manner, if the average and standard deviation are shared, without even checking each and every part, I can pinpointedly tell what is the percentage of good parts, what is the percentage of bad parts, everything I can tell with the knowledge of normal distribution. That is why people normally don't share, the population data, particularly population standard deviation, nobody will share. They will only print the average on all the website and all the product. Nobody will print the standard deviation. Because if standard deviation is printed and everything is, is transparent. Any people who know statistics, they can judge, all these things. Now you learned 4 hypothesis testing. What are the 4? One sample
t-test, one sample t-test, two sample test, t-test, ANOVA.
You become a fantastic expert now. Whenever you come across the similar scenario, use these tests. There are step-by-step approach for everything. And the best part is you don't have to remember anything. Because you just have to feed the data in Minitab and Minitab will do it. This is an AI. AI tool, right? People say AI, right? So all the steps will be performed by some software. If software is doing your job, you can call it artificial intelligence.
Mm.
Nowadays, every activity is AI powered. You can also be an AI powered green belt or AI powered black belt. You tell them, right? You don't have to do anything manually. Like you use ChatGPT or you use Minitab or you use some application, maybe an
The
Excel template,
limitation of
whatever.
that is you will never become a master black belt trainer.
But what
Simply using
happened?
GI.
People are moving very faster. You should also move with the same speed. That is also important. Speed is also important for the survival, isn't it? If you say you will learn everything and then you take 5 years time, all gone. So you learn parallelly. Now nobody is going to stop. I'm sure you all will come back to us again for the black belt and master black belt. And we are going to teach everything. We are not going to leave you, right? But when we
Yes.
teach everything in one go, and that will be a big bombardment. We don't want to do that, right? So step by step, you will learn. Okay, so this is all good for today. And so in the next class, you will see examples for each and everything, and you will see the data, and then you will also see how to feed the data and generate the analysis and refer the p-value and make the decision. That will complete hypothesis testing and indicate our readiness to move on to the next chapter, which is correlation and regression analysis. That we will do it in the next class. So next Saturday, Sunday, we will be meeting. Hope fine with all of you. Correct? Okay.
Yes, sir.
Okay, thank you so much.